What if the face on Mars, staring silently from the Cydonia plains, is no mere rock but a desperate cry from a civilization lost to time, a monument etched in stone, whispering secrets NASA dares not reveal? In 1976, Viking 1's camera captured a haunting image, a human-like visage, eyes hollow, mouth set, gazing upward as if pleading for us to remember. Is this proof of an ancient Martian society, or are we seeing shadows of our own longing in the red dust? This question, unanswered, pulls us into a mystery that refuses to let go. Good evening, dear listeners. This is Mr. H from Mystery History for Sleep, your guide through the cosmic unknown as you drift towards slumber. If this tale of Mars ignites your curiosity, consider subscribing to our channel and ringing the bell to join us for more journeys into the shadows of history. Now, let's return to that enigmatic face, its features carved not just in stone, but in the very fabric of our imagination. Picture that moment in July 1976, when humanity first glimpsed the face on Mars. The Viking 1 orbiter, orbiting a planet long shrouded in myth, sent back a photograph that shook the world. In the desolate Cydonia region, a mesa rose from the Martian surface, its contours forming an unmistakable face, eyes, nose, mouth, eerily human under the faint red light. It was no random shape. It seemed deliberate, a creation that screamed of intent. To the public, this was no mere rock. It was a beacon, a sign that Mars had once been home to intelligent beings who left their mark for us to find. The image spread like wildfire, sparking debates that burned brighter than the Martian sky. Richard Hoagland, a former NASA consultant, saw more than a face. He pointed to nearby formations, shapes resembling pyramids, aligned in patterns too precise for nature's chaos. He called Cydonia a lost city, a Martian Giza, suggesting ties to Earth's ancient civilizations. The Sumerians spoke of Anunnaki, gods from the heavens. The Egyptians built pyramids aligned with the stars. Could these be echoes of a Martian legacy, a shared history across worlds? Hoagland's claims, though bold, fueled a firestorm of speculation. Some whispered of a cover-up, that NASA knew the truth but buried it. Posts on X, even in September 2025, revive these ideas, sharing new rover images of strange shapes, boulders in rows, cliffs with unnatural curves. Are these relics of the same civilization, or are our minds weaving stories from stone? The 1,970 seconds were ripe for such mysteries. Humanity was reaching for the stars, with Viking orbiters unveiling Mars in unprecedented detail. The search for extraterrestrial intelligence, or SETI, scanned the cosmos for signals, while declassified reports hinted at UFOs near Mars's moon Phobos in 1975, moving in ways no human craft could. The face on Mars became a focal point, a canvas for our hopes of finding life beyond Earth. Was it a monument built by beings who once thrived under a red sky, or a trick of light that captivated a world eager for answers? Science, however, offered a colder truth. By the 1,990 seconds, Mars Global Surveyor's high-resolution images stripped the face of its mystique. The eyes became craters, the mouth a weathered groove. Scientists called it pareidolia, our tendency to see faces in clouds, rocks, or shadows. The face was no monument, they said, but a mesa sculpted by eons of wind and dust. By 2001, the mystery seemed closed, relegated to a footnote. Yet, in 2025, Perseverance rover images from Planitia reignited debate. A formation resembling an archway curved deliberate appeared in September's data. Scientists dismissed it as erosion, but others saw echoes of Cydonia. Why do these shapes persist, teasing us with hints of intent? The conspiracy deepens with whispers of hidden truths. Declassified CIA documents from 1984 describe remote viewing sessions where psychics envisioned Mars millions of years ago. Tall beings, pyramids, a dying world. These accounts, though doubted, fuel theories that the face was known before Vikings' cameras. X-posts in 2025 claim NASA edits rover data, citing missing images or sudden gaps. Could authorities be guarding a secret about Cydonia? Hoagland's theories stretch further, linking the face to Earth's ancient myths. The Anunnaki, he suggests, were Martians who fled their doomed planet, seeding Earth with life or culture. The pyramids of Giza, aligned with cosmic precision, mirror Cydonia's supposed grid. Is this coincidence, or a blueprint spanning worlds? Mars itself complicates the puzzle. Its surface, battered by radiation and dust storms, erases traces over billions of years. If the face was a monument, time may have blurred its edges, hiding its purpose. Nearby pyramids and city-like alignments in Cydonia suggest a mathematical order, but mainstream science sees only geology. Yet, with rovers exploring mere fractions of Mars, what lies unseen? A 2025 Perseverance image of a keyhole tomb, formation named for its shape, sparks new questions. Is it another illusion, or a glimpse of something more? The face on Mars endures because it challenges us. If a civilization existed, its relics would not resemble our cities. Built to survive Mars's thin air and cold, they might be underground, carved from stone, or eroded beyond recognition. Pareidolia explains the face, but not the longing it evokes. Why do we see purpose in these shapes? Are we projecting our desire for connection, or glimpsing a truth buried in time? As we drift deeper, the face remains a question without an answer, a shadow that beckons us to explore further. What if Mars holds more secrets, waiting beneath its dust, ready to rewrite our history? Picture this: a fragile seed hurled across the void of space, carrying the spark of life from a dying red world to a blue one teeming with potential. That seed, microscopic and resilient, lands in ancient oceans, igniting a chain of evolution that leads, billions of years later, to you and me. This isn't the plot of some forgotten myth, it's the heart of Panspermia, the theory that whispers we might all be Martians at our core, descendants of a legacy etched in cosmic dust. But how could such a transfer happen, and what fresh clues from the red planet are forcing us to rethink our origins? Panspermia isn't new. It's an idea that has simmered in scientific circles for decades, suggesting life or its building blocks hitch rides on meteorites, comets, or even dust particles between worlds. For Mars and Earth, the connection feels almost intimate. These two planets, neighbors in the solar system, share a violent history of asteroid bombardments. When a massive rock slams into Mars, it blasts fragments into space chunks of the planet itself, potentially laced with hardy microbes shielded deep within. Some of these Martian meteorites have already been found on Earth, like the famous ALH 84001, discovered in Antarctica in 1984, bearing what some argue are fossilized bacterial structures. If life emerged on Mars first, during its warmer, wetter youth, these cosmic refugees could have seeded Earth, making our biology an extension of theirs. What makes this theory pulse with new life today, in September 2025, are the latest revelations from NASA's Perseverance rover. Rolling through Jezero Crater, once a vast lakebed, the rover drilled into a rock dubbed Chayava Falls, a reddish slab speckled with leopard-like spots that scream of ancient chemistry. These spots, rimmed with white and dotted in black, contain organic molecules and minerals like hematite and sulfate, patterns that on Earth often signal microbial activity. Scientists announced this potential biosignature just weeks ago, noting how the rock's features suggest reactions fueled by water and energy sources billions of years ago. It's not definitive proof, far from it, but it's the strongest hint yet that Mars harbored conditions ripe for life, perhaps even before Earth stabilized enough to do the same. Delve deeper, and the intrigue builds. Mars cooled faster than Earth, its smaller size letting it form a habitable surface sooner after the solar system's chaotic birth. Imagine primordial soups bubbling in Martian craters, simple cells emerging amid volcanic vents or shallow seas. Then, catastrophe strikes, an asteroid impact scatters debris, including those cells, into the void. Traveling for thousands or millions of years, protected from radiation by rock layers, they crash onto early Earth. Experiments show microbes can survive such journeys. Extremophiles from our planet have endured space exposure on the International Space Station, hinting at life's tenacity. If panspermia holds, our DNA might carry faint echoes of Martian ancestry, a genetic whisper linking us to a world now frozen and barren. But panspermia isn't without its shadows of doubt and darker speculations. Some fringe voices tie it to tales of ancient migrations, drawing from declassified CIA documents from 1984. In one eerie remote viewing session, a psychic experiment under Project Stargate, a participant described Mars 1 million years before Christ as a dying planet inhabited by tall, slender beings fleeing environmental collapse. They spoke of pyramids and obelisks, structures echoing those on Earth, as if survivors seeded our world not just with microbes, but with knowledge or even refugees. Mainstream science scoffs at such claims, viewing remote viewing as pseudoscience, yet the document's vivid details vast structures, a thinning atmosphere align curiously with what we know of Mars's past. Could these visions be glimpses of a more advanced panspermia, where intelligence itself crossed the gulf? Shift the lens, and consider the methane mystery that keeps astronomers up at night. Mars's atmosphere occasionally burps plumes of methane, a gas that on Earth often stems from biological processes like bacterial digestion. NASA's Curiosity rover has detected these spikes, rising and falling with the seasons, defying easy explanations. In 2025, debates rage. Is it geology, serpentinization reactions in the crust, or something alive? Microbes thriving in subsurface pockets. Recent models suggest the methane could seep from ancient reservoirs, trapped since Mars's wet era, but the unpredictability leaves room for wonder. If biological, it bolsters panspermia. Perhaps the same microbes that escaped to Earth linger on Mars, a living link to our shared origins. Weave in cultural threads, and the theory takes on mythic proportions. Ancient texts from Sumeria describe the Anunnaki, celestial beings who shaped humanity. Could these be distorted memories of Martian visitors? Or consider indigenous stories worldwide. Speaking of star ancestors, panspermia offers a scientific gloss to these narratives, suggesting our forebears carried tales of a red homeland. In Modern Echoes, a September 2025 post on X from Starwalk captured the excitement. This is now the strongest evidence yet that life may once have existed on the red planet. But here's the catch. To confirm it, the rock sample needs to be brought back to Earth. The post went viral, sparking threads where users debated if we're staring at our own family tree. Probe further, and panspermia challenges our sense of uniqueness. If life hopped from Mars to Earth, it implies biology is robust, scattering across the cosmos like pollen on the wind. Earth's rapid emergence of life within 500 million years of its formation fits this narrative. Perhaps it didn't start from scratch but built on Martian imports. Fossil records show simple cells appearing early, mirroring what might have thrived on Mars. And if complex life followed there, panspermia could explain anomalies in our evolution, sudden leaps in complexity that puzzle biologists. Yet countercurrents swirl. Critics argue panspermia merely kicks the origin question elsewhere. If life came from Mars, where did Martian life begin? Others point to the harshness of space travel. While some microbes survive, the odds of viable transfer seem slim. But evidence mounts dozens of Martian meteorites on Earth, some with water-altered minerals, suggest exchanges were common. In 2025, analyses of these rocks reveal isotopic signatures matching Martian atmosphere, strengthening the bridge. Turn the page to implications, and the theory reshapes identity. We become cosmic nomads, our heritage spanning planets. Environmental parallels emerge. Mars lost its habitability through atmospheric stripping. Earth faces climate threats that could mirror that fate. Panspermia urges caution preserve our world, lest we become the next wanderers. Philosophically, it blurs boundaries. If we're Martian descendants, the search for extraterrestrial life is a family reunion. As threads unravel, fresh data from Perseverance adds layers. The Chayava Falls sample, sealed in a tube awaiting return, holds organic compounds in contexts screaming biology. Scientists speculate these could be remnants of microbial mats, like Earth's stromatolites. If confirmed, it tips panspermia from hypothesis to likelihood, proving Mars hosted life that could have migrated. Linger on the unknowns. Methane's source. Remote viewing's eerie accuracy. Cultural echoes. Each piece tantalizes, suggesting our story is older, vaster. Panspermia isn't just science, it's a mirror, reflecting how life persists against odds, bridging worlds in silent migration. What if, in our veins, flows the essence of a red dawn? The legacy endures, a quiet pulse from Mars, inviting us to trace it back. But the Martian heritage doesn't stop at microbes. If intelligence arose there, panspermia could carry cultural seeds, ideas, technologies, embedded in survivors or artifacts. Fringe theories posit engineered panspermia, where advanced Martians deliberately sent life to Earth, a directed genesis. While unproven, it fuels speculation. Our crop circles or ancient megaliths hints of that guidance. Another ex-post from SciTech Talkies highlighted, the rock, nicknamed Chayava Falls, is a 3.8 billion-year-old mudstone containing minerals like vivianite and greigite compounds often linked to microbial life on Earth. Such shares amplify the buzz, turning science into shared wonder. Ultimately, panspermia transforms isolation into interconnection. We're not alone in origin, we're woven into the solar system's fabric. As missions evolve, sample returns looming the truth may emerge, revealing our Martian roots. Until then, the theory beckons, a cosmic riddle wrapped in red enigma, urging us to ponder, what forgotten memories does Earth hold from its sibling world? Where are you listening from tonight, dear friends? Is it a quiet corner under a starlit desert sky? Or a cozy room in a bustling city? What hour does the clock strike in your world as you ponder this Martian legacy? Let these thoughts cradle you, a lullaby of cosmic kinship. Deep beneath the crimson veil of Mars lies a tale not of gentle decay, but of cataclysmic fury, a story whispered in the winds of conspiracy, where the red dust conceals the scars of a nuclear apocalypse that erased an entire civilization. Picture the planet's northern plains, once perhaps teeming with life, now a graveyard of anomalies that hint at explosions vast enough to scorch the world. This isn't mere speculation. It's a theory rooted in the work of plasma physicist John Brandenburg, who dared to interpret Martian data through a lens of unimaginable violence. Brandenburg posits that eons ago, massive thermonuclear blasts ravaged Mars, stripping its atmosphere and dooming any advanced society to oblivion. But were these detonations the wrath of nature, or the final act of a cosmic war waged by beings from beyond? Brandenburg's hypothesis draws from peculiar isotopic signatures in the Martian air, particularly an overabundance of xenon-129, a byproduct often linked to nuclear fission. On Earth, such anomalies appear in the fallout of weapons tests or reactor meltdowns, but on Mars, they paint a picture of planetary-scale devastation. He points to two regions, Mare Acidalium and Utopia Planitia, as ground zero for these events, where the isotopic ratios spike unnaturally high, suggesting explosions equivalent to thousands of hydrogen bombs. In one of his key papers, he describes how these blasts could have vaporized oceans, scorched biospheres, and hurled radioactive debris across the globe, forever altering the planet's fate. The red hue of Mars, he argues, might not just be iron oxide rust, but the ashen remnant of a thermonuclear firestorm that turned vibrant landscapes into desolation. What fuels the intrigue is how this theory intertwines with tangible Martian features that defy easy explanation. Vast fields of vitrified rock glass-like formations created under extreme heat dot the surface, resembling the trinitite left behind at Earth's first atomic test sites. These glassy expanses, smoothed and fused as if by a furnace from the stars, suggest temperatures soaring beyond volcanic norms. Brandenburg initially leaned toward a natural cause, like a paleo-nuclear reactor buried in the crust that went supercritical, exploding with the force of a bomb rather than melting down like Chernobyl. Yet, as data accumulated, He shifted to a bolder claim. These were deliberate detonations, perhaps weapons unleashed in an interstellar conflict. Imagine rival factions on ancient Mars, or invaders from afar, clashing in a war that left the planet uninhabitable, its survivors, if any, fleeing to safer havens like Earth. This narrative gains eerie traction when layered with observations from NASA's MAVEN mission, which has been probing the Martian atmosphere for over a decade. Recent findings reveal how solar wind particles slam into the upper layers, sputtering atoms away in a slow bleed that stripped Mars bare over billions of years. In one breakthrough observation, MAVEN captured this process in action, showing heavy ions like argon being ejected at rates that explain the planet's thin veil of air. Mainstream scientists hail this as confirmation of natural atmospheric loss, but conspiracy enthusiasts see a smokescreen. Why, they ask, does the data align so neatly with a post-nuclear scenario, where initial blasts weaken the magnetic shield, accelerating the erosion? Brandenburg weaves this in, suggesting the explosions disrupted the planet's core dynamo, leaving it vulnerable to solar assault, a 1-2 punch that doomed any lingering life. The theory's darker edges emerge in comparisons to Earth's own brushes with nuclear horror. Think of Hiroshima's shadowed imprints, or the irradiated zones around Chernobyl, where life twists in unnatural ways. On Mars, similar signatures abound. Thorium and uranium concentrations in the soil, detected by orbiters, hint at fission byproducts scattered wide. Brandenburg's book paints a vivid scene of this planetary nuclear massacre, where thriving cities, perhaps underground metropolises or domed habitats, vanished in fireballs, their echoes preserved in isotopic ghosts. But who wielded the weapons? Some speculate internal strife among Martians, a civilization advanced enough for fusion power but torn by conflict. Others invoke aliens, drawing from declassified reports of unexplained aerial phenomena that might be scouts from that long-ago war. Intriguingly, this ties into modern sightings of unidentified anomalous phenomena, like the tic-tac objects observed by pilots in recent years, sleek, defying physics, vanishing into the sea. Could these be remnants of Martian technology, survivors monitoring Earth as a potential refuge? Brandenburg himself has spoken at conferences, linking his findings to broader cosmic enigmas, suggesting the blast solved Fermi's paradox. Where are all the aliens? Perhaps they're gone, victims of their own hubris, with Mars as a cautionary tomb. Online discussions amplify this, with a recent post musing that humans once lived on Mars, fleeing a nuclear holocaust to restart on Earth, a twist on panspermia laced with apocalypse. Yet, skepticism abounds. Critics dismiss the isotopic evidence as natural, born from cosmic ray bombardment or ancient volcanism, not bombs. MAVEN's data, they argue, points solely to solar wind erosion with no need for explosive drama. Brandenburg's shift from natural reactor to alien attack has raised eyebrows, seen by some as sensationalism. Still, the anomalies persist. Why the localized spikes in radiation? Why the vitrified planes that mimic nuclear test sites? These questions linger, inviting us to peer closer at rover images, where strange craters or fused sands tease hidden truths. As we sift through this cosmic rubble, the theory evolves. Recent budget debates around MAVEN highlight tensions cuts, proposed amid whispers that the mission uncovers too much, too soon. Brandenburg's ideas echo in podcasts and forums, blending science with speculation, simulation theories positing Mars as a virtual battlefield, or occult links to ancient texts describing heavenly wars. One thread ties it to remote viewing experiments from those Cold War-era programs, where seers glimpsed Martian ruins amid radioactive haze. The allure lies in the what-ifs. If nuclear war scorched Mars, it reframes our planet as a fragile sanctuary, urging vigilance against our own destructive paths. Brandenburg's vision warns of cycles, civilizations rising, clashing, falling into dust. In quieter moments, consider the methane bursts MAVEN tracks, possibly from subsurface pockets untouched by the blasts. Could microbial holdouts survive, descendants of a pre-war biosphere? The theory beckons us to question, Was Mars's downfall a tragedy of greed or an act of cosmic pruning? As rovers trundle onward, each discovery, be it isotopic oddity or glassy shard, stirs the pot, keeping the conspiracy alive. Brandenburg's apocalypse may be fringe, but its shadows stretch long, inviting us to wonder if the red planet's wounds are self-inflicted or inflicted by hands from the stars. What secrets might the next dust storm unveil, buried in the echoes of a forgotten fire? From the earliest flickers of human consciousness, Mars has beckoned like a crimson enigma in the night sky, weaving itself into the fabric of our myths and dreams, a wanderer among stars that promised secrets beyond earthly bounds. In ancient Mesopotamia, the Babylonians gazed upon its ruddy glow and named it Nergal, the fierce god of war and plague, a harbinger of bloodshed whose erratic path across the heavens stirred omens of chaos. Why this association with violence? Perhaps it was the planet's blood-red hue, vivid even to the naked eye, evoking spilled life or raging fires. Or maybe deeper intuitions whispered of a world scarred by turmoil, a distant echo that ancient seers sensed without telescopes. This primal pull set the stage for millennia of fascination, transforming Mars from a mere light into a canvas for humanity's wildest imaginings. Shift to the sands of ancient Egypt, where the planet appeared as Horus of the horizon, a falcon-headed deity tied to kingship and the cycle of renewal. Yet even here, an undercurrent of conflict lingered. Horus battled chaos, mirroring Mars's role in Roman lore as the god of war, father to Romulus and Remus, whose name endures on the planet today. These cultures, separated by vast distances, converged on similar themes: Mars as a force of strife and transformation. Could this be coincidence? Or did early astronomers glimpse something more? Some speculate that Sumerian tablets, etched with tales of Anunnaki celestial beings descending from the skies, hint at Martian origins, gods who traversed worlds, sharing knowledge or fleeing calamity. Fringe thinkers connect these to Egyptian star alignments, suggesting ancient observatories tracked Mars not just for calendars, but for signs of otherworldly visitors. As civilizations evolved, so did the gaze upon Mars. In the Renaissance era, Galileo turned his rudimentary telescope skyward and noted the planet's phases, a revelation that chipped away at Earth-centered cosmologies. But it was in the late 19th century that Mars truly ignited modern intrigue. Italian astronomer Giovanni Schiaparelli, peering through improved lenses, sketched dark lines crisscrossing the surface, features he called canali, Italian for channels. Misinterpreted in English as canals, this sparked a frenzy. American entrepreneur Percival Lowell seized the idea, building his own observatory in Arizona to map these supposed waterways. To Lowell, they were engineering marvels, vast irrigation systems constructed by a dying civilization desperate to channel dwindling water from polar caps to equatorial farms. His books painted Mars as a tragic world, its inhabitants advanced yet doomed, a narrative that blended science with romance and captured the public's heart. Lowell's canals, though later revealed as optical illusions, tricks of the eye-blending craters and dust storms into linear patterns, unleashed a wave of speculation that endures. They inspired H.G. Wells' The War of the Worlds, where Martians, fleeing their arid home, invade Earth in tripod machines, a tale that blurred fiction and fear, especially during Orson Welles' radio broadcast that panicked listeners. This pop culture ripple extended to films like Invaders from Mars, where the red planet birthed horrors lurking beneath our feet. Even today, UFO lore circles back to Mars, with sightings of anomalous craft echoing Lowell's vision of intelligent life. Declassified documents from mid-20th century military observations describe objects near Mars's moons, moving with unnatural grace, fueling theories that ancient myths weren't fantasy but fragmented memories of interstellar encounters. Yet, the real draw lies in how these historical threads intersect with fresh revelations from our robotic explorers. In recent missions, NASA's Perseverance rover has uncovered geological oddities in Jezero crater, including mudstones laced with minerals like vivianite and greigite, compounds often tied to microbial processes in oxygen-poor environments. These findings, announced not long ago, evoke the watery past Lowell imagined, though without his canals. Instead, they suggest ancient rivers and lakes, habitats where life might have thrived. Accompanying aerial scouts, like the Ingenuity helicopter in its groundbreaking flights, captured images of layered terrains that hint at seasonal floods, adding layers to the mystery. Why do these strata resemble Earth's delta deposits, as if Mars once mirrored our blue world? Such data revives old questions. If ancient observers sensed Mars's volatility, could their gods represent actual beings who shaped early human knowledge? Delve into conspiracy corners, and the history twists further. Some claim that civilizations like the Maya or Indus Valley encoded Martian knowledge in their calendars, aligning temples with the planet's oppositions times when Earth and Mars draw closest. Perhaps these were not mere astronomical tools but beacons for contact, echoing Sumerian epics of sky gods. A viral discussion thread recently pondered if Lowell's canals were suppressed truths, with modern rovers airbrushing anomalies to maintain official narratives. But science pushes back, attributing the illusions to human perception and atmospheric haze. Yet the allure persists. Mars's polar caps, shrinking and growing with seasons observed since the telescope's dawn, fuel ongoing wonder. Could they hide subsurface oceans, remnants of Lowell's watery vision? This historical arc from mythic warrior god to illusory aqueducts reveals Mars as a mirror to our evolving psyche. In pop culture, it evolves too. From Wells's Invaders to modern blockbusters like The Martian, where survival on the red soil blends heroism with isolation. UFO films often cast Mars as a hidden base, with craft zipping through our skies as scouts from a forgotten realm. Even in ancient art, red ochre depictions of celestial battles might symbolize Martian strife, a subconscious nod to the planet's scarred visage. As we trace this path, curiosity swells. Why has Mars always evoked blood and conquest? Is it the color, the motion, or something innate, a cosmic memory embedded in our collective unconscious? Recent rover snapshots of wind-sculpted dunes, resembling ancient runes, tease at answers, blending history with the unknown. Lowell's legacy, though debunked, endures in every new image, reminding us that Mars isn't just a planet, it's a story, unfolding across epochs, drawing us ever closer to its veiled truths. What forgotten chapters might the next opposition reveal, when Mars blazes brightest, calling us to look again? Beneath the thin veil of Mars's present-day atmosphere, a hidden narrative unfolds in the planet's very bones, etched in rock layers, carved valleys, and subtle mineral whispers that speak of a time when the red world brimmed with liquid water, mirroring Earth's nurturing cradle. Imagine tracing these clues like a detective sifting through ancient clues, each discovery peeling back layers of time to reveal a Mars not as a frozen wasteland, but as a vibrant sibling planet once alive with flowing rivers, serene lakes, and perhaps vast oceans that lapped at alien shores. This evidence, pieced together from orbiters, rovers, and seismic whispers, builds a compelling case for a wetter past, one that tantalizes with questions about what might have thrived in those waters. Start with the grand canyons and valleys that scar Mars's face, features so immense they dwarf Earth's equivalents. Valles Marineris, a rift system stretching farther than the United States is wide, bears the unmistakable signatures of catastrophic floods, layered sediments, branched channels, and outflow plains that scream of water rushing with biblical force. These aren't mere cracks from tectonic whims, they're the ghosts of mega floods, perhaps triggered by volcanic heat melting subsurface ice, unleashing torrents that reshaped continents. Orbiters like those from the early 21st century missions captured these in high detail, showing how water-carved paths similar to the Colorado River's work on the Grand Canyon, but on a scale that hints at planetary drama. What volumes of water must have surged here, and for how long, to etch such deep tales into the crust? Then there are the deltas and lake beds, frozen snapshots of calmer waters. Jezero Crater, now home to a tireless rover, preserves a fan-shaped delta where sediments layered like pages in a book, deposited by a river that once fed a standing lake. Minerals here clays. Carbonates form only in the presence of persistent water, neutral pH environments ideal for nurturing early life. Recent rover drills into mudstones revealed siderite, a carbonate mineral that thrives in warm, wet conditions, providing fresh confirmation of a habitable past. These rocks, laced with organic hints, evoke visions of shallow pools teeming with chemistry, where sunlight danced on ripples. But how deep were these lakes? Some craters show shorelines terraced like bathtub rings, suggesting fluctuating levels over millennia, a cycle of filling and evaporation that could have concentrated life's building blocks. Venture northward, and the evidence swells to oceanic proportions. The northern lowlands, a vast basin covering nearly a third of Mars, bear contours that mimic ancient coastlines, sweeping arcs and layered deposits implying a body of water rivaling Earth's Arctic Ocean. Recent analyses of orbital images have imaged what appear to be coastal deposits, sediments laid down along a shoreline billions of years in the past. These features, debated yet increasingly supported, suggest an ocean that once covered the plains, its waves eroding cliffs and depositing sands. Minerals like hydrated sulfates and iron oxides, detected across these regions, form in evaporating seas, painting a picture of a salty expanse slowly retreating as the climate shifted. If true, this ocean wasn't a fleeting puddle but a stable feature, persisting long enough to foster complex interactions between water, rock, and atmosphere. Subsurface secrets add another layer of intrigue. Radar probes from orbiters in recent decades pierced the polar caps, revealing layered ice deposits that hold records of climatic swings, much like Earth's ice cores. But deeper still, seismic data from landers hints at liquid water reservoirs hidden underground vast aquifers or briny lakes insulated from the freezing surface. Marsquakes, rumbling through the crust, have unveiled structures suggesting water-saturated zones, where pressure and salts keep H2O in liquid form despite the chill. Meteorite impacts and quakes recently analyzed point to enough missing water to blanket the planet in an ocean hundreds of meters deep, locked away in hidden realms. These underground oases raise thrilling possibilities. Could they still harbor remnants of that ancient hydrology, pockets where water flows even now? The atmospheric clues tie it all together, revealing how Mars once held the warmth needed for such watery abundance. A thicker blanket of gases, rich in carbon dioxide, would have trapped heat, allowing rivers to meander and lakes to persist without freezing or boiling away. Evidence from eroded volcanoes and mineral veins shows interactions with water vapor, suggesting a greenhouse world. But orbiters tracking atmospheric escape have shown how solar winds stripped this shield, leaving only traces. Yet, in the rock record, we see the before. Hydrated minerals like vivianite in mudstones, formed in low-oxygen waters teeming with potential. These discoveries, from rover arms delving into the soil, evoke a Mars with misty mornings and rainy seasons, a far cry from today's dust devils. Ponder the anomalies that keep the puzzle alive, mysterious mounds rising from plains, shaped by ancient groundwater seeps, their forms like petrified springs bubbling from below. Or the ghost rivers, channels buried under dust but visible in radar, tracing paths of long-vanished flows. Each piece fits into a mosaic of an Earth-like past, where water sculpted the land, cycled through the air, and seeped into the ground. But gaps remain. How long did this wet era last? Estimates suggest hundreds of millions of years, enough for life to take root, yet the transition to aridity baffles. Volcanic outgassing might have replenished the air, while impacts delivered fresh water ices. Rovers continue to unearth surprises, like rocks with white veins of calcium sulfate gypsum, clear markers of water percolating through fractures, altering chemistry in ways that scream habitability. These veins, irregular and haloed, suggest not just flow but reactions that could sustain microbes. In another find, mudstones with leopard spots hold the clearest signs yet of potential ancient life, their patterns echoing Earth's microbial mats. Such evidence stirs curiosity. If Mars once hosted oceans, rivers, and lakes, what ecosystems might have flourished? algal blooms in shallows, primitive creatures in depths. This watery legacy transforms our view of Mars, a once blue world now cloaked in red silence, whispering of lost rivers and vanished seas. As rovers uncover mudstones laced with Vivianite or ghostly channels buried beneath dust, each clue deepens the enigma. What ecosystems might have flourished in those ancient waters, and how close did Mars come to mirroring Earth's vibrant cradle? The red planet's past beckons, a puzzle of possibility urging us to protect our own fragile world. Dear listeners, if these tales of Martian waters spark your curiosity, consider joining our journey by subscribing and tapping the bell to catch every cosmic whisper we share. Let your thoughts linger on those ancient shores as you drift into slumber. What secrets might the next rover core reveal, hidden in the folds of a lost ocean? Imagine Mars as a once vibrant fortress, its skies thick with protective gases, shielding a world of flowing waters and potential life from the relentless assault of space. Now, picture that fortress crumbling, layer by layer. As an invisible thief, the solar wind strips away its defenses, leaving behind a skeletal husk of dust and cold. This is the saga of Mars's atmospheric demise, a slow-motion tragedy hinged on the disappearance of its magnetic shield, a barrier that once warded off cosmic predators. But what triggered this collapse, and why does it echo warnings for our own planet? As we unravel the threads, each revelation beckons more questions, drawing us into the red planet's veiled downfall. The story hinges on Mars's lost magnetic field, a dynamo generated deep within its core, much like Earth's, which deflects charged particles from the sunday. Without this invisible armor, the atmosphere becomes prey to the solar wind, a stream of energized protons and electrons barreling through space at millions of kilometers per hour. These invaders collide with atmospheric molecules, knocking them loose in a process scientists call sputtering, where atoms are ejected like sparks from a forge. Recently, NASA's MAVEN orbiter captured this sputtering in action for the first time, observing argon ions being hurled away as solar wind pummeled the upper atmosphere. This direct glimpse reveals how Mars bleeds its air, molecule by molecule, a fate sealed when its magnetic protection faded billions of years ago. Why did the shield fail? Clues lie in the planet's interior, probed by landers that listen to its seismic heartbeat. Marsquakes, rumbling through the crust, suggest a core that solidified long ago, halting the convective flows needed to sustain a global magnetic field. Unlike Earth's molten dynamo, which churns iron and nickel to generate protective lines of force, Mars's core grew still, perhaps cooled by its smaller size or ancient impacts that disrupted its heat engine. Recent models propose that this shutdown wasn't uniform. Remnants of magnetism linger in crustal rocks, magnetized stripes hinting at a field that once flipped poles like Earth's, but eventually weakened to pockets of local protection. These fossil fields, frozen in volcanic basalts, whisper of a transitional era when Mars teetered on the brink, its atmosphere beginning to unravel. As the magnetic barrier dissolved, the solar wind struck with full fury. Early orbiters in the 1,970 seconds glimpsed the thin air less than 1% of Earth's density, but it took missions like MAVEN, launched in the early 21st century, to map the escape routes. MAVEN's instruments track how heavier gases like carbon dioxide and nitrogen flee, but lighter ones like hydrogen from water vapor vanish even faster, explaining why Mars's once abundant oceans evaporated or froze underground. In a striking observation, MAVEN witnessed atmospheric sputtering directly, where solar particles slam into the exosphere, dislodging atoms at rates that could have depleted the entire atmosphere over eons. This process accelerates during solar storms, when the wind intensifies, carving away at Mars like a cosmic sandblaster. The intrigue deepens with the role of water in this decline. Mars's early atmosphere likely held enough greenhouse gases to keep surfaces warm, allowing liquid water to carve valleys and fill basins. But as the field waned, ultraviolet rays split water molecules high up, freeing hydrogen to escape while oxygen sank, oxidizing the soil to its rusty red. This oxidative theft not only dried the planet but locked away potential biosignatures, burying them in iron-rich regolith. What if microbial life clung on during this transition, adapting to thinning air before the final chill set in? Seismic data from recent landers hints at subsurface brines, salty liquids insulated from the freeze, where pressure and chemistry might preserve pockets of habitability. These hidden realms tease at survival stories, worlds beneath the world where the atmosphere's loss didn't spell total doom. Counterintuitively, Mars's mini-magnetospheres, those crustal remnants, add a twist. In regions like the Southern Highlands, ancient rocks hold magnetic imprints strong enough to deflect some solar wind, even today. Maven has flown through these bubbles, noting how they bend incoming particles, creating localized shields that might have prolonged habitable niches long after the global field collapsed. Imagine ancient oases persisting under these patchy protections, ecosystems evolving in isolation as the broader planet desiccated. Yet, these are fragile. Solar erosion chips away, raising questions about how long they can last. The solar wind's influence extends to Mars's interaction with the interplanetary magnetic field, draping around the planet like a cloak. Recent studies show how this draped field orients closed magnetic loops on the dayside, aligning with upstream forces in ways that modulate atmospheric loss. During periods of strong solar activity, escape rates spike, potentially explaining episodic bursts in methane or other gases detected by rovers. This variability stirs curiosity. Could ancient solar flares have accelerated the decline, delivering knockout blows that tipped Mars from wet to wasteland? Fringe speculations weave in, suggesting the field's loss wasn't purely natural. Perhaps a catastrophic impact or internal upheaval shattered the dynamo, echoing theories of planetary trauma. Declassified observations from mid-20th century telescopes noted anomalies in Mars's ionosphere, hints of irregular magnetic behavior that fuel debates today. What if the shutdown coincided with a cosmic event, like a nearby supernova bathing the planet in radiation, weakening its core? Earth offers a stark contrast, its robust field deflecting most solar assaults, preserving our blue skies. But Mars's fate warns of vulnerability. Our own field has weakened over centuries, flipping poles in the geologic past. Could human activities hasten a similar erosion here? As Maven continues its vigil, mapping escape in real time, each dataset unveils more about this cosmic heist. The orbiter's findings on sputtering highlight Mars's exposure, a vulnerability born from a silenced core. Linger on the unknowns. Why did the dynamo quiet so early in Mars's history? Seismic whispers from landers suggest a solid inner core, resolving old debates but opening new ones about heat loss and composition. Perhaps ancient volcanism sustained it briefly, only for cooling to prevail. These puzzles beckon future probes, drills piercing the crust to sample core echoes. Mars's atmospheric unraveling isn't just history, it's a mystery unfolding, with each solar gust carrying away clues. What remnants of that lost shield might we detect, buried in polar ices or equatorial sands? The red planet's decline, from shielded haven to exposed relic, captivates, urging us to ponder if similar fates await other worlds or our own. Whispers from the red sands suggest a Mars not eternally silent, but once humming with the subtle rhythms of existence, microscopic at first, perhaps evolving into forms that challenge our wildest speculations. What if the building blocks of life assembled there in primordial pools, sparking chains of complexity that mirrored Earth's own ascent? This exploration dives into the tantalizing potential for life on Mars, starting with hardy microbes that could have endured its harsh cradle, then venturing toward the elusive possibility of more intricate beings. Each clue uncovered by probes and analyses stirs the imagination, leaving us to ponder, how far might evolution have ventured on a world so similar, yet so estranged from our own? At the foundation lies the microbial realm, where life's simplest forms might have taken root in Mars's ancient wet havens. Rovers, probing Jezero crater, have unearthed mudstones rich with organic molecules, carbon-based compounds essential for biology, interwoven with minerals like vivianite and greigite. substances often linked to microbial metabolism in Earth's anaerobic environments. These organics, detected in rocks showing signs of prolonged water exposure, evoke scenarios of bacteria thriving in hydrothermal vents or shallow ponds, drawing energy from chemical reactions rather than sunlight. On Earth, such extremophiles flourish in scalding springs or frozen tundras, hinting that Mars's early conditions warmer, wetter, with volcanic activity could have mirrored these niches. But the intrigue lies in the ambiguity. Are these molecules relics of life, or abiotic artifacts forged in geochemical crucibles? Recent rover findings in a formation dubbed Bright Angel amplify the mystery, with rocks bearing potential biosignatures, patterns of elements, and structures that scream of biological processes, yet demand earthly labs for confirmation. Push further, and the question evolves: could these microbes have clustered into communities, forming biofilms or mats that altered their surroundings? Earth's stromatolites, layered microbial edifices from billions of years past, offer a template. On Mars, layered deposits in craters suggest similar accumulations, where cyanobacteria-like organisms might have harnessed faint sunlight to produce oxygen, subtly shifting the atmosphere. Seismic whispers from landers reveal subsurface structures potentially harboring briny liquids, insulated pockets where microbes could persist even today, metabolizing minerals in the dark. Methane plumes, sporadically erupting from the soil and detected by orbiters, add fuel on our planet. Such gas often stems from bacterial digestion, though geology could mimic it. What mechanisms drive these bursts on Mars? If biological, they point to resilient life forms enduring the planet's chill, a hidden biosphere pulsing beneath the regolith. Transition to complexity, and the narrative thickens with speculation grounded in evolutionary logic. If microbes dominated Mars's early epochs, akin to Earth's first 3 billion years, could they have bridged to multicellularity? The planet's habitable window, estimated at hundreds of millions of years with stable water and energy, might have allowed for such leaps. Consider eukaryotic cells, Earth's game changers that fused symbionts to power intricate structures. Similar mergers could have occurred in Martian lakes, fostering diversity. Theories propose that weaker gravity and unique radiation exposure might have spurred novel adaptations, like radiation-resistant fungi or algae carpeting volcanic slopes. Yet, oxygen scarcity poses a hurdle. Complex life on Earth thrives on it, but Mars's thin air suggests anaerobic pathways, perhaps yielding gelatinous colonies or worm-like burrowers in sediments. Envision ecosystems emerging, shallow seas hosting filter feeders, drawing nutrients from mineral-rich waters, or underground networks where chemosynthetic organisms formed vast webs, akin to Earth's deep-sea vents. Volcanic regions, with their heat and chemicals, could have been cradles for diversity, supporting proto-animals that sensed light or chemicals. But time constrains this vision. Mars's cooling core and atmospheric thinning likely shortened the evolutionary runway, potentially stalling at simple forms. Still, anomalies intrigue. Unusual rock textures resembling fossilized burrows, spotted by rovers in ancient deltas, spark debates, biogenic or mere erosion. If complex, they imply motility, predation, perhaps even symbiosis, elevating Mars from microbial outpost to a world of budding intricacy. Delve into intelligence's shadow, and curiosity peaks. Evolution isn't linear. On Earth, it took eons for brains to emerge, driven by environmental pressures. Mars's challenges, drying climates, dust storms might have selected for clever survivors, burrowing creatures evading radiation, or communal organisms sharing resources. Fringe models suggest if habitability lingered longer than thought, social behaviors could arise, leading to tool use or signaling. But evidence whispers caution. No clear fossils surface, though subsurface ice layers might preserve them, as recent studies propose microbes finding refuge beneath frozen caps. Terraforming theories flip the script, pondering if ancient Martians engineered their world, but science leans toward natural limits. The methane enigma recurs. with seasonal spikes hinting at active biology, perhaps complex enough for metabolic cycles involving multiple species. Rovers sniffing the air detect these, but origins elude. Life or geochemistry? If the former, it suggests resilience, microbes evolving defenses against desiccation. Organic-rich rocks from Jezero, with their leopard spots of potential microbial origin, bolster this white rims of calcium sulfate encircling organic halos, patterns echoing Earth's ancient life signs. These Sapphire Canyon samples, sealed for return, hold promise. Vivianite veins suggesting water flow, and irregular shapes defying abiotic explanations. Contrast with Earth's timeline. Life here exploded in diversity after oxygenation, but Mars's path diverged, perhaps yielding anaerobic marvels fungi, like networks spanning craters, or colonial blobs pulsing with chemical signals. Astrobiology theories posit that given energy, gradients, and time, complexity isn't inevitable but probable. Mars's hydrothermal sites, mirrored in Earth's origins, could have sparked it. Yet, the red planet's silence challenges: did evolution halt at microbes, or did traces erode away? Ponder the subsurface. Radar hints at liquid layers, where pressure sustains water, fostering ecosystems isolated from surface woes. Here, complex forms might endure, tube worms feeding on chemical seeps, or microbial mats evolving symbioses. Viking experiments from the 1970 seconds stirred controversy, with labeled release tests suggesting metabolic activity, though dismissed as chemistry. Recent re-evaluations revive debate. This spectrum from single cells to speculative societies fuels endless wonder. If microbes seeded Mars, complexity's ghost lingers in every rock. Sample returns loom, promising clarity, but until then, the potential tantalizes. What evolutionary wonders might Mars conceal? A parallel path cut short. Envision a Martian dawn billions of years past, where slender figures emerge from domed shelters carved into rust-hued cliffs, their forms adapted to a gravity that tugs gently, their lungs drawing in air, laced with the faint tang of recycled oxygen. This is the speculative heart of a Martian civilization, not a mirror of Earth's bustling cities, but a symphony of ingenuity forged in the crucible of unrelenting adversity. Low gravity eases burdens but weakens bones. Radiation pierces unprotected skin. Dust storms blot out the sun for months. Yet, in this harsh ballet, survival demands innovation, raising questions that tease the mind. How might intelligent beings on Mars have bent their world to their will, crafting societies that thrived where we might falter? Let's wander through this hypothetical landscape, layer by layer, uncovering adaptations that blend science's edges with the thrill of the unknown. Begin with shelter, the first bastion against Mars's merciless embrace. Surface dwellings would succumb to cosmic rays and temperature swings, plummeting to -60 degrees Celsius at night. So, logic points underground, vast networks of caverns hollowed from lava tubes, natural refuges formed by ancient volcanic flows. These tubes, detected by orbiters in recent missions, span kilometers, their stable interiors shielding from radiation while geothermal heat warms the depths. A civilization might expand them into multi-level habitats, walls reinforced with regolith bricks fused by microwave sintering, a technique Earth engineers now test for lunar bases. Imagine chambers lit by bioluminescent fungi engineered from local microbes, or mirrors channeling faint sunlight through fiber optics, creating oases of dim glow amid the dark. But adaptation runs deeper. Inhabitants could evolve or genetically modify for low-light vision, their eyes enlarged like deep-sea creatures, turning perpetual twilight into a canvas for intricate art, etched in phosphorescent minerals. Water, that elusive elixir, shapes every facet of this envisioned society. With surface liquids boiling away in the thin air, Martians might harvest subsurface aquifers. Radar hints at vast briny reservoirs hidden beneath polar caps, insulated from freeze. Ingenious pumps, powered by wind turbines harnessing dust-laden gales, could draw this saline bounty, desalinating it through solar evaporation domes or microbial filters. Agriculture adapts accordingly. Hydroponic gardens in sealed greenhouses, crops like hardy tubers bioengineered for low pressure, thriving on nutrient-rich volcanic soil. Geothermal vents, bubbling with heat from Olympus Mons' lingering warmth, provide energy for vertical farms stacked in cavern layers, where LED lights mimic a stronger Sunday. What diets emerge? Perhaps fungi-dominated feasts, mushrooms blooming in humid alcoves, supplemented by algae ponds that recycle carbon dioxide into oxygen, a closed-loop system mirroring Earth's biosphere but tuned to scarcity. The curiosity spikes. Could such farms support populations in the millions? Or did resource limits foster nomadic clans migrating between oases? Energy harvesting becomes a cultural cornerstone in this unforgiving realm. Solar panels, dusted daily by robotic swarms, capture the distant sun's rays, but storms demand backups, geothermal taps drilling into hot rock for steam turbines, or nuclear fission from thorium deposits abundant in Martian crust. Recent rover analyses of thorium hotspots suggest natural reactors might have once formed underground, inspiring theories of ancient Martians harnessing fission for power grids spanning craters. Wind farms atop plateaus exploit the thin but fierce gales, blades spun from lightweight composites derived from local silicates. Transportation evolves around these sources. Maglev tracks in vacuum-sealed tunnels, propelled by electromagnetic pulses, linking habitats without fuel waste. Rovers, precursors to wheeled caravans, traverse dunes on balloon tires inflated with captured atmospheric gases. But intrigue builds with mobility's risks. Radiation exposure during surface treks might necessitate suits woven from regolith-derived fabrics, embedded with magnetic deflectors mimicking a lost planetary field. Social structures molded by environment intrigue with their potential uniqueness. Low gravity allows towering architectures inside caverns, spires reaching hundreds of meters without collapse, perhaps serving as observatories peering through thin atmosphere at distant stars. Communities cluster around geothermal hubs, fostering hierarchical societies where heat keepers hold sway, guardians of energy allotments in a world where warmth equals life. Rituals might revolve around solstices, when Mars's elongated orbit brings closer solar warmth, celebrated with dances that leverage weak gravity for aerial feats impossible on Earth. Language adapts to vocalizations, softened for thin air, supplemented by gestures or bioluminescent signals on skin implants. Education emphasizes survival sciences, children learning to repair habitats from childhood, their myths woven with tales of the Great Thinning, a cultural memory of atmospheric loss that drives innovation. Conspiracy threads weave in, amplifying the enigma. Formations in Cydonia, with their pyramid-like shapes aligning curiously with Earth's Giza complex, spark whispers of shared blueprints. Perhaps Martians influenced ancient human builders through panspermia or direct migration. Fringe voices link this to Atlantis legends, positing a Martian diaspora seeding lost Earth civilizations, their tech adapted from Red World hardships. Recent rover images from Jezero crater reveal leopard spots on rocks like Shiava Falls, organic-rich patterns that, while microbial hints, fuel speculation of engineered artifacts. Could these be fossilized remnants of bioengineered barriers against erosion? A September 2025 announcement from NASA described these as potential biosignatures, with white calcium sulfate rims encircling organic halos, patterns echoing deliberate designs rather than random chemistry. Skeptics call it pareidolia, but the alignment with ancient Earth monuments teases. What if Martians, adapting to decline, encoded messages in stone for future discoverers? Defense and expansion pose further riddles. Against meteor barrages, early warning networks of seismic sensors dot the surface, triggering dome reinforcements or evacuations to deeper bunkers. Expansion might involve terraforming trials releasing greenhouse gases from polar ices to thicken air, a process mirrored in modern Earth proposals, but perhaps attempted eons ago, only to fail amid core cooling. Societies could splinter, surface nomads in mobile habitats, scavenging resources, versus subterranean clans hoarding geothermal wealth, leading to conflicts resolved through resource barters rather than wars. Given the fragility of life support, cultural expressions adapt ingeniously. Art forms utilize dust as medium sculptures shaped by wind tunnels, or holographic projections from crystal lattices grown in labs. Music resonates in low-pressure chambers, instruments vibrating membranes tuned to thin air's acoustics, evoking haunting melodies that carry far. Spirituality might center on the Red Mother, the planet itself, with pilgrimages to ancient craters revered as birthplaces of life. But adaptation's cost. Physical evolution under low gravity could yield elongated limbs, fragile frames, necessitating exoskeletons for labor. Radiation's toll might spur genetic tweaks, creating castes specialized for surface or depth dwelling. Recent Curiosity rover encounters with boxwork terrain ridged, hollowed nodules resembling engineered lattices add fuel, suggesting natural formations that a civilization might mimic for habitats. These, alongside turtle-shaped rocks and helmet-like outcrops, blur lines between geology and artifice, stirring questions. Did Martians sculpt their world, or did environment sculpt them? Theories from astrobiology circles propose that if life advanced, it would prioritize sustainability, perhaps developing fusion from helium-3 inches regolith, powering domed cities that recycled every atom. As we speculate, the harshness breeds resilience, a civilization where innovation is prayer, adaptation the creed. Low oxygen demands efficient metabolisms, perhaps symbiotic implants filtering air. Communication spans via neural links, evolved from necessity in isolated bunkers. But decline looms, thinning air, forcing deeper retreats, societies condensing into core strongholds. What legacies remain? Buried archives in magnetic crystals, or signals beamed to stars, awaiting our ears. This Martian tapestry, woven from environmental imperatives, captivates with its vision of resilience. Underground cities pulsing with geothermal life, farms defying arid desolation, cultures sculpted by scarcity's hand. Anomalies like thorium spikes or boxwork terrains tease at lost ingenuity, blurring nature and artifice in a dance of survival. As probes peel back the red planet's secrets, each discovery, organic veins, cryptic ridges, stirs wonder. What innovations might we unearth? Echoes of a civilization that dared to thrive where we might falter. Dear listeners, if these tales of Martian tenacity spark your curiosity, dive deeper into our Lost Civilizations playlist, where more stories of forgotten worlds await to guide your dreams. Let these visions of red world resilience lull you into slumber. What hidden legacies might whisper through the dust, calling us to imagine civilizations unbowed by the void? Good night, and may your dreams weave through these crimson caverns. In the shadowed recesses of a hypothetical Martian existence, survival wasn't a given, it was a relentless gauntlet, where every dawn brought battles against an environment that seemed engineered for extinction. Picture these ancient inhabitants not as conquerors of their world, but as tenacious improvisers, constantly recalibrating their lives around dwindling resources and escalating threats. Water, that most precious commodity, became the axis of their society. Energy, the flickering heartbeat keeping darkness at bay, and environmental conflicts, the ever-present spectres shaping their ingenuity or sealing their doom. As we navigate this imagined crucible, each adaptation unveils layers of resilience, prompting us to wonder, how close did they come to mastery, and what lessons might their struggles hold for our own fragile tenure on a neighboring world? Water's scarcity transformed from inconvenience to existential imperative as Mars's atmosphere thinned and its surface froze. In this arid theatre, sourcing the liquid essence of life demanded feats of engineering rooted in the planet's hidden bounties. Subsurface aquifers, vast reservoirs of briny water insulated beneath layers of permafrost, offered a lifeline radar. Echoes from recent orbiters suggest these could span continents, pockets where geothermal warmth prevents total solidification. Hypothetical Martians might have drilled deep with tools forged from iron-rich ores, employing thermal lances heated by volcanic vents to pierce the ice caps. Once tapped, purification became an art. Electrochemical filters, drawing on science's principles of electrolysis, could separate salts, yielding potable streams recycled through closed systems. Imagine communal wells in cavern hubs, where water was rationed by crystalline meters, each drop a currency of survival. But contamination loomed dust-infiltrating seals, or microbial blooms turning sources toxic, forcing nomadic shifts to fresher veins. Curiosity arises. Did they bioengineer algae strains to desalinate, harnessing photosynthesis in dimly lit hydro chambers, or did desperation breed conflicts over dwindling springs, clans guarding oases with barricades of fused regolith? Energy's pursuit mirrored this ingenuity, a quest to harness Mars's meager offerings amid perpetual twilight. Solar power, though abundant in theory, faltered under months-long dust storms that blanketed panels in ochre shrouds. To counter, a civilization might deploy autonomous cleaners, swarms of beetle-like drones, powered by piezoelectric crystals vibrating in the wind, scuttling to clear surfaces. Geothermal taps plunged into the planet's cooling core, where lingering heat from ancient eruptions like those of Olympus Mons provided steam for turbines, generating electricity in vast underground plants. Science illuminates possibilities. Thorium deposits, abundant in Martian soil as detected by rovers, could fuel compact reactors, their fission sustaining habitats without the bulk of Earth's uranium setups. Wind farms atop mesas exploited the thin but ferocious gales, blades spun from lightweight composites derived from silicate sands. Yet, storage posed riddles, batteries crafted from local lithium veins, or supercapacitors, using carbon nanotubes grown in lab vats. What innovations emerged from blackouts? Perhaps kinetic harvesters, pendulums, swinging in low gravity to capture motion, or biofuel from engineered fungi, digesting regolith organics. The mind wanders. Did energy hierarchies form, with elites controlling geothermal nodes, or did communal grids foster unity, each habitat linked by superconducting cables buried against radiation? Environmental conflicts amplified these challenges, turning adaptation into a high-stakes dance with doom. Radiation, unchecked by a vanished magnetic field, bombarded the surface like an invisible siege, mutating cells and eroding materials. To endure, Martians might retreat to shielded depths, lining caverns with water-ice barriers that absorbed cosmic rays, a natural armor drawn from polar harvests. Suits for surface forays could incorporate magnetic coils, generating personal fields to deflect particles, echoing Earth's auroral protections, but miniaturized with superconducting threads. Low gravity, a deceptive ally, eased construction but atrophied muscles and leached bone density. Countermeasures might include centrifugal habitats, spinning cylinders simulating weight, or gene therapies boosting calcium uptake from mineral diets. Dust storms, planetary tempests engulfing the globe, blinded sensors and corroded machinery defenses could involve electrostatic shields repelling particles, or predictive networks using seismic precursors to seal domes in advance. Temperature extremes compounded the ordeal, plunging nights to abyssal colds while days scorched under unfiltered Sunday. Insulation. Innovations might feature aerogel foams derived from silica sands, trapping heat in habitat walls, or phase change materials, shifting states to regulate climates. Conflicts arose from seismic unrest, Marsquakes cracking aquifers, releasing toxic gases like perchlorates that poisoned water supplies. Rovers have uncovered such compounds in the soil, hinting at chemical hazards that could have forced relocations or sparked purification revolutions. Imagine societies evolving rituals around quake seasons, shamans interpreting tremors as planetary warnings, guiding migrations to stable terrains. Resource wars simmered beneath these trials, water and energy becoming flashpoints in a world of finite supplies. Clans might clash over geothermal vents, forging alliances through shared pipelines, or descending into skirmishes with dust-camouflaged ambushes. Low oxygen demanded respiratory aids masks filtering carbon dioxide into breathable mixes, or implants enhancing lung efficiency, blending biology with tech. Psychological strains loomed. Isolation in bunkers, breeding cabin fever, mitigated by virtual realms projected on cavern walls, simulating lost oceans. Did art flourish as escape? Murals depicting verdant pasts using pigments from iron oxides. Recent rover revelations heighten the speculation. In Jezero crater, mudstones laced with vivianite, a mineral tied to water, and potential microbial energy suggest environments where life could have harnessed chemical gradients for survival. These findings, announced just weeks ago, evoke a Mars where ancient beings might have biomined such compounds for fuel cells, adapting to energy scarcity with microbial batteries. Perchlorate-rich soils, once seen as toxic, could have been detoxified through engineered enzymes, turning poison into propellant for rockets escaping the decline. Health battles raged too, radiation-induced ailments, prompting medical marvels, like regenerative therapies from stem-like cells cultured in zero-G labs. Conflicts with microgravity might yield exoskeletal fashions, wearable frames enhancing strength while serving as status symbols. As resources waned, innovation peaked. Fusion prototypes, fusing helium-3 from regolith, or atmospheric processes condensing trace water vapor during rare humid spells. This web of challenges paints a civilization in perpetual flux, each solution birthing new puzzles. Water hunts leading to seismic traps, energy quests exposing to storms, environmental foes forging unbreakable bonds or bitter rifts. Science's glimpses, radar, aquifers, thorium maps tease at feasibility, but the human element intrigues. Did hope sustain them? Visions of a restored world driving megaprojects like atmospheric reinjection? Or did despair fracture societies, remnants burrowing deeper as the surface claimed the bold? The enigma captivates. In Mars's craters, do artifacts of these struggles await, tools etched with desperation's genius? As our probes scratch the surface, each core sample whispers of resilience, urging us to reflect on our own vulnerabilities, water wars on Earth, energy crises looming. What if Martian survival tales, hypothetical yet haunting, mirror our future, a cosmic caution woven from red dust and unyielding will? The red planet's hypothetical hardships beckon, a tapestry of triumph and tragedy, leaving us to muse. How far would we go, faced with such odds, to cling to the spark of life? Time etches its unforgiving script across every world, but on Mars, it's a master storyteller of loss, weaving tales through relentless erosion, unshielded radiation, and cataclysmic meteor strikes that have all but erased what might have been a thriving chapter of history. Imagine standing on the red plains, feeling the whisper of wind-carried dust abrading your suit, the sun's harsh rays piercing through a veil too thin to protect, while the ground beneath trembles with the echoes of ancient impacts. This isn't mere decay, it's a systematic obliteration, a planetary amnesia that hides potential relics of life or civilization beneath layers of time, warns silence. As we delve into this cosmic vanishing act, each force reveals its role, leaving us to question what secrets have been ground to dust, and could any fragments still defy the onslaught, waiting for our probes to uncover them? Erosion on Mars operates like a patient sculptor, reshaping the surface with winds that howl unchecked across a landscape devoid of vegetation or oceans to temper them. These gales, laden with fine regolith particles, act as natural sandblasters, polishing rocks into ventifacts, strangely faceted stones, that mimic artifacts but are born of abrasion alone. In regions like the Gale crater, where rovers have traversed for over a decade, layered outcrops tell of wind's tireless work, stripping away softer materials to expose harder veins, creating ridges and yardangs that stretch like skeletal fingers. Science shows these processes accelerate in the thin atmosphere, where low pressure allows dust to lift easily, forming global storms that can engulf the planet for weeks, depositing and eroding in equal measure. Recent orbital imagery captures these tempests in action, revealing how they redistribute sediments, burying potential fossils or structures under meters of drift. But the curiosity lies in the subtlety. Could subtle alignments in these eroded forms, straight edges or symmetrical hollows, be remnants of intentional design, weathered beyond recognition? Rovers have documented boxwork terrains, intricate networks of raised ridges resembling honeycomb, formed as wind exploits mineral weaknesses, yet their patterns tease at something more ordered, blurring the line between nature's chaos and forgotten intent. Radiation adds a insidious layer to this erasure, a silent assassin bombarding the surface with cosmic rays and solar particles that break down molecules and degrade materials at the atomic level. Without a global magnetic field, Mars lacks Earth's protective bubble, exposing its skin to fluxes 10 times higher than our planet's. This barrage ionizes organics, shattering carbon chains that might preserve biosignatures, turning potential evidence of life into fragmented whispers. In the equatorial zones, where radiation peaks, soil samples from rovers show perchlorates, reactive compounds formed by this exposure that could have sterilized shallow layers, oxidizing any biological remnants. Deeper probes hint at survival zones. Subsurface ices might shield against this onslaught, preserving frozen archives where radiation's reach fades with depth. Recent lander data from seismic sensors reveals how these rays penetrate, altering rock chemistry and creating secondary particles that cascade further. What intrigues is the potential for adaptation if life or artifacts existed. Could they have been engineered with radiation-resistant coatings, like boron-infused shields drawn from local minerals? Anomalies in rover spectra suggest zones of anomalous mineralization, perhaps natural barriers or deliberate fortifications, raising questions about what might lurk just below the irradiated crust. Meteor impacts deliver the dramatic punctuation to this tale of obliteration, cosmic hammers slamming into Mars with frequencies far higher than Earth's. Thanks to the thin air offering little resistance, these strikes excavate craters that pockmark the surface like ancient battle scars, ejecting debris across vast distances and reshaping terrains in instants. The Hellas Basin, a colossal depression wider than Europe, testifies to a mega impact that could have vaporized oceans and triggered global quakes, burying evidence under kilometers of rubble. Smaller barrages, like those forming the Barringer-like features scattered across the plains, pulverize rocks into breccias, jumbled fragments that mix and mask older layers. Orbiters have mapped these fields, showing how fresh impacts expose subsurface ices, only for sublimation and wind to reclaim them swiftly. The thrill comes from the dual nature. Impacts destroy, but also exhume, flinging materials that preserve snapshots of deeper history. Meteorites from Mars found on Earth, altered by these events, carry isotopic clues of past atmospheres, but on the red planet itself, the crater's rims erode over eons, their ejecta blankets smoothing into oblivion. Recent telescopic observations note ongoing micrometeorite showers, peppering the surface and accelerating breakdown. Could these have obliterated surface ruins, scattering artifacts into unrecognizable shards? Interplay among these forces creates a compounding effect, a symphony of destruction where erosion smooths impact scars, radiation degrades exposed ejecta, and storms redistribute the remnants. In the polar regions, sublimating ices carve spider-like areniforms, channels that mimic burrows but form from gas eruptions, further complicating the search for genuine traces. Subsurface realms offer refuge. Lava tubes and caves, insulated from above, might harbor preserved relics, their stable microclimates defying the surface chaos. Landers have detected these voids through ground-penetrating echoes, vast networks where erosion's touch is minimal, radiation attenuated, and impacts muffled. What if microbial fossils or tool fragments lie there, untouched by the triad of tormentors? Theories propose that ancient life retreated underground, evolving in isolation as the surface succumbed, leaving biosignatures in salt deposits or frozen brines. This erasure isn't uniform. Southern highlands, battered by eons of exposure, show more degradation than northern lowlands, perhaps once shielded by oceans. Rovers traversing these terrains document wind-sculpted dunes, migrating like living entities, burying and unearthing in cycles that tease at hidden layers. Radiation's role in perchlorate formation adds a chemical twist, these salts acting as oxidants that could have bleached organic evidence. Yet in briny pockets, they might preserve it by inhibiting decay. Impacts shock waves, propagating through the crust, fracture rocks and release volatiles, potentially creating transient habitats even as they destroy. The enigma deepens with anomalies that defy easy dismissal. Unusual polygonal cracks in craters, resembling desiccation patterns but aligned too precisely, or vitrified glasses in impact melts, fused sands that echo nuclear residues but stem from meteoric heat. Recent MAVEN data on atmospheric sputtering ties in, showing how solar wind exacerbates erosion by lofting dust particles, a feedback loop accelerating the wipeout. InSight's seismic logs reveal Marsquakes triggered by impacts, vibrations that crumble fragile formations, scattering potential clues. Ponder the timescales. Over billions of years, these forces have recycled the surface multiple times, with turnover rates estimated at centimeters per millennium for wind erosion alone. Radiation doses accumulate to lethal levels in mere months on the surface, degrading DNA or materials swiftly. Impacts, averaging one major event every few million years, reset local clocks, obliterating histories in fireballs. Yet, perseverance probes like those in Jezero crater drill into protected strata, unearthing mudstones with organic halos that survived this gauntlet, their leopard spots hinting at resilience. These, rimmed in calcium sulfate, suggest water-mediated preservation amid the chaos. This planetary purge captivates with its thoroughness, a cosmic editor redacting Mars's story. But gaps invite speculation, shielded enclaves where traces endure, or orbital debris carrying ejected artifacts. As human missions loom, drilling deeper, we edge closer to piercing this veil. What if a single unweathered shard rewrites the narrative, proving life's tenacity against erasure? Mars's vanished traces, ground by wind, seared by rays, shattered by stones, whisper of impermanence, urging us to seek what defies the void. In this red amnesia, what forgotten echoes might resurface, challenging our understanding of survival in the cosmos? Amid the crimson desolation of Mars, where dust devils dance like spectral guardians and craters gape like ancient wounds, certain formations rise from the regolith, defying easy explanation and igniting endless debate. These are not mere rocks or ridges. They are enigmas sculpted by a world of extremes, pyramid, like mounds that echo earthly wonders, wall-like escarpments stretching toward infinity, all veiled in the psychological trickery of Pareidolia, where the human mind imposes order on chaos. In this harsh arena, the environment itself plays the antagonist, its winds, radiation, and isolation conspiring to craft illusions that blur the boundary between natural geology and potential artifice. Embark first on the plains of Cydonia, a region that has long captivated those who scan orbital images for signs of intent. Here, pyramid-shaped hills cluster in alignments that, from certain angles, mimic the geometric precision of Egypt's Giza complex. These formations, rising abruptly from the flatlands, feature faceted sides and apexes that catch the light in ways suggesting deliberate construction. Early orbital photographs from the 1970 missions revealed these anomalies, prompting theorists like Richard Hoagland to propose they form a city layout, complete with mathematical ratios echoing sacred geometry. Hoagland argued for artificial origins, perhaps monuments erected by a civilization adapting to environmental collapse, their bases fortified against encroaching dust. Yet, high-resolution scans from early 21st century orbiters dismantled much of this, attributing the shapes to layered volcanic deposits eroded differentially by wind-harder caps protecting softer bases, creating stepped profiles over eons. The harsh Martian winds, whipping particles at velocities amplified by low gravity, carve these illusions, much like Earth's hoodoos in arid badlands. But the puzzle persists. Why do these pyramids align with the infamous face nearby? And could subsurface scans reveal hidden chambers, insulated from radiation's degrading touch? Recent radar data hints at voids beneath similar features elsewhere, teasing at natural caves or something more engineered, where a society might have sheltered from solar flares. Venture southward to the Elysium Planitia, where wall-like structures snake across the landscape, elongated ridges that from orbit resemble fortified barriers or ancient ramparts. These escarpments, sometimes kilometers long and meters high, display unnaturally straight edges, prompting whispers of defensive walls built by Martians to hold back encroaching deserts or channel scarce floods. Fringe interpretations link them to Sumerian myths of celestial strongholds, suggesting interstellar architects who fortified against environmental fury. Science counters with glacial origins. These could be moraines, debris pushed by ancient ice flows during wetter epochs, their linearity preserved as the ice sublimated away. The planet's extreme temperature cycles, freezing nights contracting materials, thawing days expanding them further fracture and align these features, while relentless radiation weathers exposed surfaces into polished facets. Intriguingly, rover traverses in analogous terrains have uncovered polygonal cracks radiating from these walls, patterns formed by thermal stress but evoking deliberate tiling. What if these cracks conceal access points to underground networks, protected from Meteor micropunctures? A recent orbital survey noted similar linear anomalies in the southern highlands, where dust accumulation softens edges, blurring whether wind alone sculpted them or if intelligent hands guided the process. Pareidolia emerges as the great deceiver in this tableau, the brain's innate urge to recognize patterns faces in clouds, animals in rocks amplified by Mars's alien austerity. This psychological phenomenon explains why a mesa in Cydonia morphs into a humanoid face under oblique lighting, its eyes mere craters shadowed just so. Early images fueled this illusion, but refined views from Mars Global Surveyor in the early 2000s resolved it into eroded buttes, the mouth a landslide scar. Yet, Pareidolia thrives in harsh climes. The environment's uniformity endless reds. Sparse features forces the mind to impose familiarity, turning random erosion into perceived order. Radiation plays a subtle role, altering surface colors and textures to create high-contrast patterns that enhance visual tricks. Consider the D and M pyramid in Cydonia, a five-sided hill that some claim bears tool marks. Science attributes it to tectonic fracturing and wind honing, but its symmetry in low-res scans sparks ongoing debate. Rovers have encountered similar optical teases, boulders resembling helmets or turtles, their shapes honed by aeolian abrasion in a world where dust acts as a universal eraser. The question lingers: does Pareidolia mask genuine anomalies, or does the brain's bias dismiss what might be subtle remnants of design, weathered by cosmic rays that break down even stone over millennia? These controversial shapes don't exist in isolation. The harsh environment interlinks them, a web where erosion, radiation, and impacts collaborate to confound. Meteor strikes pummel the surface, excavating fresh material only for wind to redistribute it, creating hybrid forms that blend old and new. In the Tharsis region, volcanic mounds resemble stepped pyramids, their layers from lava flows but aligned in ways that intrigue alignment theorists. Radiation's flux, varying with solar cycles, preferentially degrades organics or softer rocks, leaving harder silicates to form stark geometric relics. Dust storms, global behemoths that can last seasons, deposit fine layers that smooth contours, turning jagged outcrops into rounded walls over time. Recent atmospheric models show how these storms loft particles high, where radiation ionizes them, creating charged veils that further etch the land. Pareidolia feeds on this. In low-light orbital shots, shadows elongate features, transforming natural buttes into towering edifices. Conspiracy lenses amplify the mystery, positing these as deliberate constructs pyramids, as observatories tracking Phobos' erratic orbit, walls as barriers against ancient floods. Declassified remote viewing sessions from Cold War programs described Martian ruins with pyramidal forms, visions dismissed as fantasy but echoing these shapes. Mainstream views lean on geology. Differential erosion in a carbon dioxide dominated air caves preferentially, creating illusions amplified by our Earth-biased eyes. Yet, anomalies persist, unexplained magnetic signatures around some pyramids, detected by orbiters, hinting at metallic inclusions or ancient fields. Could these be natural magnetite deposits, or remnants of tech shielding against radiation? The harshness itself might preserve clues paradoxically. In shadowed craters, where dust settles slowly, formations endure longer, their details crisp against the regolith. Rovers probing these sites uncover veined rocks resembling constructed lattices, their origins debated as hydrothermal deposits or something crafted. Pareidolia's role evolves with tech AI enhancements in recent images, sharpen edges, sometimes revealing symmetries that challenge natural explanations. What if these are hybrid? Environment sculpting over artificial bases, time's collaboration with intent. This interplay of Martian shapes, pyramids, walls, shadows captivates with its ambiguity, a dance where nature and intent blur in the red world's harsh embrace. As rovers probe deeper, each image teases at truths hidden beneath dust, urging us to question what we see, mere geology or relics of a forgotten hand. The enigma of Sidonia's forms, sculpted by wind or will, remains unresolved, a riddle that lingers in the quiet of your night. From where are you tuning in, dear listeners? Perhaps a seaside town where waves echo Martian shores, or a mountain cabin under a moonlit glow. What time does your evening hold as these mysteries unfold? Let Mars's controversial contours guide your dreams, a canvas of possibility stretching across the void. Good night, and may your slumber unveil the secrets buried in those red sands. In the arena of cosmic inquiry, where Mars's red vistas tease with hints of ancient wonders, mainstream science stands as a stern gatekeeper, wielding the blade of skepticism to slice through claims of extraterrestrial civilizations. This isn't a dismissal born of rigidity, but a disciplined dance with evidence, demanding rigor that tantalizes as much as it frustrates. The allure of pyramids, faces, or walls on Mars, shapes that spark dreams of lost societies, collides with the cold calculus of scientific standards, where extraordinary claims require extraordinary proof. Yet, within this clash lies a gripping tension. What does it take to convince the gatekeepers, and could their caution obscure truths buried in the Martian dust? Science's bedrock is repeatability observations that hold across instruments, locations, and time. When early orbiters in the 1970 seconds captured the face on Mars in Cydonia, its human-like features ignited speculation of intelligent design. But later missions, with sharper lenses, revealed a weathered mesa, its eyes mere craters, its mouth a landslide scar. This transformation, driven by higher resolution, exemplifies the scientific demand for clarity over suggestion. Pareidolia, the mind's trick of seeing patterns like faces in random forms, became the explanation, not artifice. Mainstream researchers argue that similar logic applies to pyramid-like hills or linear ridges. What seems deliberate often resolves into geology under scrutiny. Wind erosion, sculpting Martian regolith into facets, mimics structure. Radiation alters textures, creating false symmetries. These natural processes, studied through decades of orbital data, align with Earth's own eroded landscapes, requiring no alien architects. The burden of proof escalates for claims of civilization. A single photograph, no matter how evocative, falls short. Science demands physical artifacts, tools, inscriptions, or chemical signatures of technology, like those that confirm Earth's ancient cities. On Mars, rovers have found organic molecules in Jezero craters' mudstones, laced with minerals suggesting water-driven chemistry, but these hint at microbial life, not societies. Recent analyses of rocks like Chayava Falls show leopard spots that could be biosignatures, Yet mainstream voices stress the need for Earth-based lab confirmation to rule out abiotic mimics. Without such rigor, claims of advanced life remain speculative, lacking the concrete markers, say, fossilized machinery or isotopic anomalies distinct from natural decay that science requires. Skepticism deepens with Mars's harsh environment, which obliterates evidence over billions of years. Erosion by dust storms, relentless radiation, and meteor impacts grind down potential relics, as seen in the smoothed craters of the southern highlands. Earth's oldest ruins, mere thousands of years old, struggle to survive. Expecting Martian structures to endure eons seems improbable. Seismic data from recent landers shows constant surface turnover, with quakes fracturing and burying layers, further erasing traces. This temporal erasure fuels scientific caution. Even if civilizations existed, their signatures might be indistinguishable from geology, demanding subsurface probes or sample returns to uncover preserved clues. Conspiracy whispers challenge this restraint, suggesting suppression. Some claim NASA filters images, citing pixelated rover feeds or missing data as evidence of hidden ruins. These echo broader distrust, like moon landing hoaxes, but science counters with transparency. Raw images are public, and anomalies often stem from compression, artifacts, or lighting. A recent post mused about erased Cydonia structures, yet mainstream rebuttals point to open archives disproving tampering. Still, the skepticism isn't absolute dismissal. Scientists remain open to microbial evidence, with rovers actively seeking biosignatures. The leap to civilizations, however, lacks the physical or chemical fingerprints needed to shift paradigms. This rigor captivates with its paradox. Science's high bar protects against illusion but risks missing subtleties. Anomalies like magnetic spikes in Cydonia's pyramids or aligned ridges in Elysium tease at possibilities, yet without context, say, a verifiable artifact, they stay in the realm of conjecture. The process mirrors Earth's archaeology, where context distinguishes ruins from rocks, but Mars offers no inscriptions or pottery, only eroded hints. Recent rover finds, like Vivianite veins suggesting water-driven life, keep the door ajar, but the threshold for civilization remains dauntingly high. What if science's caution masks a truth too alien to recognize? As probes dig deeper, each sample tests the boundaries of skepticism. Could a single relic, a metallic shard, a deliberate isotope upend the orthodoxy? Or will Mars's silence reinforce it? This tension between rigorous denial and tantalizing possibility fuels curiosity, urging us to question whether the red planet's secrets are merely mirages or truths awaiting a bolder lens. We turn our gaze to the cataclysmic symphonies that may have reshaped Mars, a world scarred by colossal forces that dwarf our earthly tempests. Imagine the red planet not as a serene desert, but as a stage for planetary upheavals. Asteroid barrages that hammered its crust like divine anvils, and volcanic behemoths erupting with fury to cloak the skies in ash and gas. These disasters, woven into Mars's ancient fabric, whisper of a history fraught with violence, where survival hung by a thread and the very landscape bears the imprints of chaos. As we explore these titanic events, each detail unfolds like a shadowed riddle, inviting us to question how such calamities might have extinguished possibilities or, paradoxically, sparked new beginnings in the void. Let us first descend into the abyss of asteroid impacts, those celestial intruders that have pelted Mars with unrelenting ferocity. The planet's surface is a testament to this bombardment, pocked with craters that range from modest dimples to basins vast enough to swallow entire continents on Earth. Take the Hellas Planitia, a colossal depression, deeper than Mount Everest, is tall and wider than the distance from New York to Denver, a scar from an impact so monumental it could have vaporized global oceans and triggered seismic waves rippling across the globe. Such strikes, occurring in the solar system's turbulent youth, would have unleashed shock waves fracturing the crust, melting rock into glassy ejecta, and lofting debris high into the thinning atmosphere. Recent analyses suggest these events left remnants embedded deep within the mantle, dozens of mysterious blobs, dense and anomalous, detected through seismic whispers from landers. These fragments, likely shards from massive collisions billions of years ago, indicate a sluggish churning of the interior, preserving the wreckage of failed planets that never coalesced. The intrigue swells. Could these impacts have delivered water, rich comets, seeding temporary havens amid the destruction? Or did they sterilize nascent life with sterilizing heat and radiation pulses? Smaller barrages continue even now, with micrometeorites peppering the surface daily, eroding features and mixing soils in ways that confound our search for relics. Orbiters have captured fresh craters forming in real time, their bright rays of ejecta fading as dust reclaims them, a reminder that Mars remains a target in the cosmic shooting gallery. What buried treasures or horrors might these strikes have unearthed or entombed? Layers of history compressed under impact melts. Now, ascend to the volcanic titans that crown Mars's horizon, monuments to inner turmoil that make Earth's volcanoes seem like mere firecrackers. Olympus Mons, the solar system's loftiest peak, towers thrice the height of Everest. Its gentle slopes, a deceptive calm masking eruptions that once blanketed the planet in lava flows spanning oceans worth of area. This shield volcano, born from a hot spot that pierced the crust without tectonic plates to shift it, would have spewed basaltic seas, reshaping vast regions into plateaus of solidified fire. But the drama lies in the chemistry. Recent simulations reveal how these outbursts released sulfur-rich gases, forging temporary greenhouse veils that trapped heat and perhaps sustained wetter climes for extended periods. Imagine plumes of sulfur dioxide soaring into the stratosphere, reacting with trace water to form acid rains that etched canyons or nourished exotic chemistries in hydrothermal pools. The Tharsis Bulge, a swollen dome hosting this volcanic quartet including Ascraeus, Pavonis, and Arcia Mons, warped the planet's very axis, tilting it and altering climates in ways that could have triggered floods or frozen epochs. Seismic sensors from recent landers have detected rumbles echoing from these giants' depths, hints of lingering magma chambers that might still bubble with potential. The question tantalizes: did these eruptions foster life in warm vents, providing energy gradients for microbial genesis, or did their ash clouds choke the skies, plunging the world into prolonged winters that doomed emerging ecosystems? These disasters didn't act in isolation. They intertwined in a planetary pas de deux of destruction and renewal. Asteroid impacts could have punctured volcanic reservoirs, unleashing hybrid cataclysms, mega floods of lava mingling with vaporized ice, carving outflow channels like those snaking from Valles Marineris. Such events might have lofted aerosols high, scattering sunlight and cooling the globe, or injected volatiles that briefly thickened the air, creating fleeting habitable windows. The Hellas impact, for instance, may have triggered antipodal volcanism on the opposite side, birthing the Tharsis rise through shock wave, focusing a cosmic ricochet reshaping hemispheres. Recent mantle models, informed by seismic data, suggest these collisions injected dense debris that slowed convection, preserving volcanic hotspots far longer than on Earth. This interplay raises profound curiosities. Could life have adapted in the aftermath, thriving in impact, heated lakes or sulfur-laced fumaroles, evolving resilience against recurring apocalypses? Or did the cumulative toll tsunamis of molten rock, acid veils smothering the sun, extinguish sparks before they flared? The scale alone mesmerizes. Olympus Mons caldera could engulf Los Angeles, its flows paving areas larger than France in a single outburst. Impacts like Borealis Basin, potentially covering the northern hemisphere, might have resurfaced half the planet, erasing prior histories in a molten reset. Yet, preservation occurs in paradoxes, ejecta blankets insulating underlying strata, volcanic ash layers sealing biosignatures like time capsules. Rovers probing these terrains uncover mudstones with leopard spots, organic patterns that survived such upheavals, their rims of calcium sulfate hinting at water persisting amid the fire. These survivors stir wonder. What microbial refugia might have endured in subsurface havens, shielded from the surface infernos. Fringe echoes amplify the mystery, linking these disasters to myths of heavenly wars or alien interventions, where impacts were weapons and volcanoes, battlegrounds. Mainstream views frame them as natural milestones, pivotal in Mars's transition from wet haven to arid tomb. But anomalies persist, unexplained seismic blobs in the mantle, perhaps impact remnants, defying models of mixing. As orbiters map fresh craters and landers listen for quakes, each signal peels back layers, teasing at the red planet's violent biography. These cataclysms, from sky-fallen hammers to earth-born furies, captivate with their raw power, a reminder of cosmic fragility. Mars, once perhaps a cradle, became a forge of extremes, impacts birthing basins, volcanoes crowning heights. What evolutionary leaps or extinctions did they catalyze? As our probes delve, the red world's disasters beckon, their echoes a lullaby of ancient tumult, urging dreams of worlds remade in fire and stone. A tale of Panspermia, where Mars emerges not as a barren sibling, but as the potential cradle from which Earth's vitality sprang. Picture microscopic voyagers, encased in rocky vessels, hurtling through the void on asteroid fragments, bridging the red planet's ancient seas to our blue horizons. This hypothesis, once whispered in the margins of science, now pulses with fresh intrigue, challenging us to trace the hidden pathways of existence itself. As we follow this interstellar migration, each scientific strand reveals wonders and uncertainties, inviting us to wonder, if life traversed the gulf between planets, what echoes of that journey linger in our own cells? And how might recent discoveries on Mars rewrite the origins we thought we knew? Panspermia unfolds as a grand cosmic dispersal, proposing that life or its precursors drifts through space, seeded from world to world via comets, asteroids, or even interstellar dust. In the context of Mars and Earth, this becomes a familial saga. Two neighboring planets, forged in the solar system's fiery birth, exchanging material in a perpetual dialogue of debris. Asteroid impacts on Mars, unleashing plumes of rock into orbit, propel fragments across the void, some eventually captured by Earth's gravity. Dozens of such Martian meteorites have been identified on our planet, their compositions matching the red world's unique isotopic fingerprints, gases like argon and nitrogen trapped within, echoing Mars's ancient atmosphere. One famed example, discovered in Antarctica during the 1980 seconds expeditions, bears microstructures that some interpret as fossilized microbes, though debates rage over their biotic origins. The journey itself defies intuition. These rocks endure the vacuum's chill, cosmic radiation's barrage, and fiery atmospheric entry, yet experiments show hardy microbes can survive such ordeals. Earth's extremophiles, bacteria thriving in radiation-soaked reactors or Antarctic ices, offer analogues, suggesting life's tenacity could bridge planetary divides. Delve into the mechanics, and the narrative captivates with its precision. When a massive impact strikes Mars, excavating craters like those dotting Hellas Basin, it ejects material at escape velocities, flinging it into elliptical orbits that intersect Earth's path. Transit times vary. Some fragments arrive in mere thousands of years, others linger for millions shielded within rock matrices that buffer against space's hazards. Upon entry, Earth's thicker atmosphere cushions the fall, preserving interiors where microbes might slumber in stasis. Recent models simulate these trajectories, estimating that tons of Martian material rain down annually, a steady cosmic drizzle potentially ferrying biological cargo. If Mars hosted early life in its wetter phase, rivers carving valleys, lakes pooling in craters, this exchange could explain Earth's rapid biological emergence, life appearing soon after our planet cooled, as if gifted a head start from its red neighbor. The intrigue deepens with biosignatures unearthed by rovers, bolstering Panspermia's plausibility. In Jezero crater, mudstones riddled with leopard spots, organic-rich patterns rimmed in white calcium sulfate, suggest ancient microbial activity, minerals like vivianite and greigite, hinting at reactions in oxygen-poor waters. These findings, announced in early September 2025 by NASA, evoke scenarios where bacteria metabolized iron or sulfur, leaving chemical footprints that mirror Earth's primordial soups. If such life flourished on Mars first, its smaller size allowing quicker cooling and habitability impacts could have blasted these microbes skyward, seeding Earth during its formative turbulence. Panspermia's variants add layers: lithopanspermia via rocks, ballistic panspermia from impacts, or even directed panspermia, where intelligent beings intentionally dispatched life. Fringe extensions tie this to myths of star-seeded humanity, but science focuses on the microbial, with meteorites like those from Mars showing water-altered minerals that could cradle dormant cells. Counter-arguments weave doubt into the fabric, enriching the mystery. Critics note panspermia merely shifts life's origin, question elsewhere if from Mars, then whence Martian life? Survival odds seem slim. Space's vacuum desiccates, radiation mutates, and entry heats to incineration. Yet, lab tests expose microbes to simulated journeys, many enduring, their spores encased in salt or clay shields. Earth's tardigrades, microscopic water bears, withstand vacuum and radiation, suggesting analogues could hitch rides. Atmospheric escape data from orbiters like MAVEN shows Mars shedding material continuously, a slow bleed that could include biological traces. Recent simulations estimate that over the solar system's lifespan, billions of tons of Martian rock have reached Earth, a volume ample for probabilistic seeding. Cultural resonances amplify the tale's allure, echoing ancient lore where gods descend from heavens, perhaps distorted memories of cosmic arrivals. Sumerian Anunnaki or indigenous star ancestors might symbolize panspermia's essence, life as a wanderer unbound by single worlds. In modern echoes, a recent analysis posits that if panspermia holds, humanity's quest for Mars becomes a homecoming, our probes seeking ancestral roots in red soil. The theory gains traction amid 2025's biosignature buzz, with Mudstone's organic halos suggesting microbial mats that could have been ejected intact during impacts. These potential biosignatures, as NASA frames them, feature irregular shapes and chemical contexts defying easy abiotic explanations, fueling debates on whether life's journey began under a red sky. If panspermia is real, does it imply life's ubiquity, scattering like pollen across the galaxy? Directed versions raise dilemmas. Should we seed other worlds, risking contamination or ethical overreach? Recent discussions explore ethical value in such acts, weighing benefits against unknowns. For Mars-Earth links, it reframes identity. We as Martians, our biology, a transplant thriving in a new garden. Meteorite exchanges continue today, with Martian arrivals estimated at 500 kilograms daily, a silent migration persisting. If confirmed, it dissolves isolation, binding planets in biological kinship. Uncertainties abound, captivating the mind, proving direct transfer demands matching genetic signatures between Martian finds and Earth life, a feat awaiting sample returns. Biosignatures like those in Chiava Falls, with their Vivianite veins and organic cores, offer tantalizing previews, but contamination risks loom. Panspermia's journey, from red craters to blue seas, embodies resilience, a cosmic relay where life defies voids. If this cosmic journey captivates you, dear friends, why not subscribe and ring the bell to stay woven into our starry tales? Share your thoughts below. Does the idea of Martian ancestry stir your imagination? Let these questions carry you into the night. Imagine peering into the red planet's past, its vanished rivers, shadowed craters, and whispers of ancient life, and realizing it mirrors our deepest roots, reshaping our sense of self from solitary earthlings to cosmic heirs of a shared legacy. This notion, born from theories like panspermia and bolstered by tantalizing clues from rovers, invites us to question the very narrative of who we are, blending scientific intrigue with philosophical wonder. Consider the profound shift in identity that unfolds if panspermia holds true, a scenario where microbial life, or its precursors, journeyed from Mars to Earth aboard rocky emissaries ejected by ancient impacts. Earth's early biosphere, emerging swiftly after the planet's fiery formation, takes on new meaning, not a spontaneous miracle in primordial soups, but a continuation of Martian vitality, transplanted and flourishing in a more hospitable realm. This reframes humanity not as the pinnacle of isolated evolution, but as descendants of interstellar wanderers, our DNA potentially laced with red planet resilience. Philosophical ripples extend to our myths, ancient tales of sky-fallen gods or starborn ancestors, from Sumerian epics to indigenous lore, might encode fragmented memories of this cosmic migration, transforming folklore into veiled history. What cultural artifacts, then, might we reinterpret through this lens? The red ochre in cave paintings, symbolizing blood or fire, perhaps an unconscious nod to our Martian heritage. The intrigue intensifies with recent rover revelations that lend credence to this interconnected saga. In Jezero Crater, a rock formation examined by NASA's Perseverance rover bears leopard spots, organic-rich patterns, encircled by white rims of calcium sulfate, suggesting ancient chemical reactions in water-laden environments that could have hosted microbial life. These features, with their irregular shapes and mineral associations like vivianite, evoke processes on Earth tied to early biology, raising the possibility that such life forms could have been blasted into space during Mars's volatile past, seeding our world. If confirmed through sample returns, this doesn't just affirm habitability, it bridges identities, making us Martians by descent, our blue planet a second home, where the red world's legacy bloomed into forests, oceans, and conscious minds. This shared history alters our self-perception from unique creators of destiny to participants in a solar system spanning continuum, where life's tenacity defies planetary boundaries. Extend this to societal impacts, and the narrative grows even more compelling. Human history, chronicled in stone tablets and digital archives, suddenly expands beyond Earth's horizons, incorporating Mars's geological saga as prelude. Our migrations, from African savannas to global sprawls, mirror potential Martian exoduses fleeing environmental decline, adapting to new realms. Environmentalism gains urgency. Mars's transformation from wet haven to arid tomb warns of our own vulnerabilities, climate shifts echoing its atmospheric stripping. If we inherit Martian resilience, perhaps it equips us for stewardship, inspiring technologies like biodomes or genetic edits drawn from extremophile studies. Ethically, it challenges anthropocentrism life as portable, not Earth-exclusive, prompting re-evaluations of space exploration. Are we colonizers or reclaimers, returning to ancestral grounds? Religiously and spiritually, the implications stir profound curiosity. Creation stories across cultures, divine sparks igniting life, might symbolize Panspermia's cosmic delivery, gods as metaphors for asteroid couriers. Abrahamic traditions of a singular origin evolve into multi-planetary tapestries. Eastern philosophies of interconnectedness find validation in shared biospheres. Indigenous views of star relatives gain scientific resonance, fostering dialogues that blend ancient wisdom with rover data. What rituals might emerge from this? Ceremonies honoring the red star as progenitor, or meditations visualizing microbial journeys, reconnecting us to cosmic kin. Psychologically, this redefined identity fosters humility and unity. No longer apex predators of a lone world, we become threads in a vast web, our conflicts petty against solar scales. Mental health paradigms shift. Existential angst eased by belonging to a resilient lineage that survived planetary cataclysms. Education transforms curricula, weaving Mars's geology with human evolution, inspiring youth to see themselves as interstellar nomads. Art and literature flourish. Novels reimagining Martian forebears, paintings blending red dunes with blue seas, evoking a hybrid heritage. Yet, uncertainties temper the wonder, keeping the enigma alive. Biosignatures like those in Jezero's mudstones, organic halos in redox-driven contexts, hint at microbial pasts, but abiotic mimics loom, demanding lab scrutiny. If panspermia prevails, it questions free will. Are we products of chance cosmic transfers, or destined inheritors? Genetic studies might reveal Martian echoes, unexplained DNA sequences resilient to radiation, traits forged in red crucibles. Socially, this narrative bridges divides, shared origins dissolving borders, fostering global cooperation in Mars missions as family reunions. Economically, it spurs industries biotech mining Martian analogues for medicines, space tech advancing sustainability. But risks emerge. If Martian life influenced us, could dormant pathogens lurk in meteorites, or ethical dilemmas arise in reclaiming the red world? This fusion of histories captivates, a mirror where Mars reflects our essence. If its ancient waters birthed our spark, humanity's story stretches across voids, a saga of migration and adaptation. Recent findings amplify this. Minerals like greigite in rover samples suggest energy sources for early life, pathways that could have traversed to Earth. We stand at a threshold, rover data teasing at revelations that could redefine selfhood from Earthbound to solar citizens. Envision a symphony of steel and silicon rovers etching paths through forgotten craters, orbiters charting subsurface shadows, and perhaps soon, human boots, imprinting the regolith as we step into the future of exploration. This is no mere catalogue of machines and missions. It's the birth of interplanetary archaeology, a quest to unearth not just rocks and relics, but the very threads of cosmic kinship that bind us to the red planet. With discoveries unfolding even now in this year of 2025, we stand on the cusp of answers that could illuminate our shared origins, stirring the soul with questions. What if tomorrow's probes don't just map Mars, but rewrite the human story, turning dust into destiny? Let us begin with the tireless sentinels already at work, their wheels grinding truths from the Martian soil in ways that echo the meticulous digs of earthly archaeologists sifting for pharaohs' tombs. NASA's Perseverance rover, that intrepid wanderer dispatched in the early 2022s, has become a cornerstone of this new epoch, its arm a precise trowel unearthing layers of the planet's veiled past. Just weeks ago, in mid-September 2025, the mission team unveiled findings from a rock dubbed Chayava Falls, a mudstone plucked from Jezero Crater's ancient riverbed, its surface etched with leopard spots that gleam like cryptic runes under the rover's gaze. These irregular patterns, rimmed in white calcium sulfate and laced with organic molecules, whisper of chemical dances billions of years old, potentially driven by microbial hands in water-saturated havens. Vivianite and greigite, minerals born of iron and sulfur reactions in low oxygen depths, adorn the sample, evoking Earth's own microbial mats where bacteria forged life's early bonds. Not definitive proof, the scientists caution, but a tantalizing biosignature demanding return to earthly labs for deeper dissection. As Perseverance seals these cores in titanium tubes, part of the Mars Sample Return Campaign, a collaborative odyssey with international partners, we glimpse the archaeology unfolding, not swords or scrolls, but chemical fossils that could confirm life once stirred under a red sky, perhaps seeding our own blue cradle. This sample quest marks a pivotal turn, transforming robotic reconnaissance into a deliberate hunt for heritage. The Mars Sample Return, slated for culmination in the late 2022s or early 2030s, envisions a relay of ingenuity. Perseverance caches specimens, a fetch rover retrieves them, a sky crane launches them skyward, and an orbiter captures the capsule for the long-haul home. Upon arrival, pristine vaults await sterile chambers where spectrometers and microscopes will probe for unambiguous signs, from chiral amino acids to isotopic ratios, screaming biology. Imagine the revelations. If these rocks harbor Martian microbes ghosts, interplanetary archaeology blooms, our tools evolving from picks to plasma etchers, mapping not just terrain but timelines of evolution. Curiosity's earlier jaunts in Gale Crater, unearthing organics in clay-rich strata, laid the groundwork, but 2025's biosignature buzz elevates the stakes. Jezero's delta, once a lakefront, now a vault of potential, its sediments layered like forgotten folios awaiting translation. Yet, the future unfurls broader wings, embracing subsurface odysseys that treat Mars as a stratified archive. Its crust, a library of lost epochs, upcoming missions, whispered in planning halls from NASA to the European Space Agency, promise drills piercing kilometers deep, chasing briny aquifers glimpsed in radar shadows beneath the polar caps. These hidden realms, insulated from radiation's ravage, might cradle extant life microbes in salty seclusion, their metabolisms a bridge from ancient oceans to today. Envision cryogenic coras, robotic augers humming through permafrost, extracting ices laced with organics for isotopic storytelling. Such ventures echo earthly paleontology, where Antarctic drills yield dinosaur-era air bubbles. On Mars, they could exhume atmospheres from wetter eras, revealing climatic tipping points that doomed the Red World. The allure lies in the unknowns. What extremophiles might lurk in these depths? And how might their biochemistry, perhaps sulfur, based or radiation, hardened redefine life's frontiers, offering blueprints for our own deep space ambitions? Humanity's direct touch adds a poetic layer to this archaeological renaissance, shifting from remote proxies to embodied discovery. SpaceX's Starship prototypes, tested in recent years, herald crude forays by the decade's end, boots treading Jezero's shores where Perseverance now roams. These pioneers, clad in pressurized exosuits, become living lenses, eyes attuned to subtle cues machines might miss, like faint etchings in wind-sculpted stones or anomalous alignments in boulder fields. Interplanetary archaeology demands this intuition, a gloved hand brushing regolith to reveal a keyhole tomb, a formation resembling an access portal to buried vaults, or tracing a linear ridge that defies erosion's chaos. Training regimens already simulate this, astronauts poring over rover feeds, honing skills to distinguish pareidolia from purpose, much like archaeologists discerning tool marks from fractures. What epiphanies might arise? A human spotting a geometric fracture pattern, prompting ground-penetrating radar to unveil a lava tube lined with crystalline artifacts, or a chance seismic reading during a surface trek revealing hollows beneath pyramids in Cydonia. The canvas expands with international collaborations, weaving a global tapestry of curiosity. The European Space Agency's Rosalind Franklin rover, a twin to Perseverance in spirit, targets Oxia Planis for its clay-rich clays, launching soon to drill for organics in strata hinting at ancient shorelines. China's Tianwen series, with its orbiter lander rover trio, probes Utopia Planitia for subsurface ices, its instruments attuned to methane plumes that tease at biological whispers. These missions form a constellation of eyes, cross-verifying data to build a unified Martian chronicle, Jezero's biosignatures corroborated by Oxia's minerals, Utopia's quakes mapped against Tharsis's rumbles. Private ventures add wildcard flair, SpaceX's uncrewed scouts scouting landing sites, or Blue Origin's habitats testing long-term digs. This polyphony fosters a new discipline, exoarchaeology, blending geology, astrobiology, and anthropology to interpret alien contexts, where a ruin might be a natural vent or a deliberate marker. Ethical shadows dance alongside the excitement, a reminder of our role as cosmic custodians. Protocols for planetary protection, refined in recent decades, mandate sterile approaches to avoid contaminating potential Martian life rovers sterilized to molecular purity, human crews quarantined upon return. If interplanetary archaeology unearths relics of intelligence, do we claim them as heritage or leave them in situ, preserving a site's sanctity? Indigenous perspectives, consulted in mission planning, urge viewing Mars as kin, not conquest rituals blessing launches, stories framing discoveries as dialogues with ancestors. These considerations infuse the quest with depth, exploration not as plunder, but as revelation, unearthing truths that humble our hubris. As 2025's milestones, Perseverance's cache swelling, sample return architectures solidifying propel us forward, the horizon shimmers with promise. Envision orbital telescopes peering into lava tubes via laser altimetry, or swarm drones excavating Cydonia's enigmas, their findings streamed to global labs in real time. Interplanetary archaeology, once a dream, materializes as a bridge between worlds, turning Mars's silence into song. What if a single core from Chayava falls? Its spots blooming under electron microscopes confirms life's red origins, igniting a renaissance in human identity. Or a human archaeologist, kneeling in Jezzero's delta, brushes away dust to reveal a fossilized imprint, a microbial colony, or something more sentient echoing our own first steps. Picture yourself not as an observer of distant dust storms, but as a thread in an interstellar tapestry, where the red planet's silent demise serves as both cautionary parable and ancestral whisper. This reflection isn't a linear recounting of facts or fancies. It's a mosaic of musings, drawing from the wells of human thought to explore how Mars's story compels us to confront our own vulnerability, while hinting at a heritage that spans solar voids. Let us begin by contemplating fragility, that delicate balance where life teeters on the edge of oblivion, a theme Mars embodies with haunting eloquence. The red planet, once perhaps a cradle of flowing waters and temperate climes, now stands as a monument to impermanence, a world where atmospheres thinned to whispers, oceans retreated into icy tombs, and any budding vitality succumbed to the inexorable grind of time. This transformation serves as a stark allegory for our own earthly perils. Consider how Mars's magnetic shield faltered, exposing its skies to solar winds that stripped away protection layer by layer, much like humanity's ongoing dance with climate shifts, where rising seas and scorching heats erode the buffers we've long taken for granted. Philosophers like Epicurus spoke of atoms swirling in the void, forming fleeting structures. Mars literalizes this, its eroded valleys and dust, choked craters reminding us that stability is illusion, a momentary pause in entropy's march. What intrigues is the parallel to human hubris societies, rising in defiance of nature, only to crumble when resources wane. If Mars harbored life, its extinction or retreat underground echoes our own existential risks, pandemics, resource wars, or technological overreach that could tip our world toward a similar desolation. The curiosity lies in the resilience implied. Perhaps, like extremophiles burrowing into Martian regolith, humanity possesses an innate adaptability, a cosmic inheritance urging us to fortify against fragility before the void claims us too. This warning extends beyond environmental woes, delving into the philosophical core of identity and purpose. Mars's potential as life's origin, via mechanisms like panspermia, reframes our narrative from isolated triumph to interconnected humility, a legacy where we are not the universe's sole protagonists, but bit players in a solar drama. Think of it as a Copernican revolution redux. Just as Galileo displaced Earth from the cosmic center, Mars displaces us from uniqueness, suggesting our blueprint may have been drafted under a red sky. This stirs profound questions. If microbial forebears traversed the void on asteroid arcs, does that infuse our essence with Martian tenacity, a genetic whisper of survival against odds? Existentialists like Camus might see absurdity in this struggling against an indifferent cosmos, yet it offers meaning. Life as a defiant bloom, propagating across worlds despite fragility. The red planet's scars, from impact basins to volcanic remnants, become metaphors for our own wounds, from conflicts or calamities that, if heeded, could foster wisdom. Intriguingly, this legacy might manifest in subtle ways. Our fascination with red hues in art, or innate drives toward exploration, as if ancestral memories beckon us back. What if our myths of fallen paradises encode this cosmic fall, a red Eden lost to desiccation, urging us to cherish our blue one? Delving deeper, Mars's fragility illuminates the ethical imperatives of our cosmic stewardship. As we ponder interplanetary archaeology probes sifting for biosignatures in Jezzero's mudstones, we confront the responsibility of not repeating history's errors. The red world's atmospheric unraveling, perhaps accelerated by volcanic outgassings or solar assaults, parallels our carbon-laden skies, a caution that unchecked progress invites ruin. Philosophers of ecology, drawing from thinkers like Aldo Leopold, advocate a land ethic extended to planets, treating Mars not as quarry, but kin, its legacy a call to sustainable expansion. This raises tantalizing dilemmas. If we confirm Martian origins, does it grant us rights to reclaim the red world, terraforming its wastes into gardens, or does fragility demand we preserve its silence as a monument to loss? The curiosity swells with bioethical twists if panspermia seeded us. Might we owe a debt to revive Mars, engineering atmospheres or ecosystems as restitution? Recent rover glimpses, like organic halos in water-veined rocks, amplify this. They could be ancestral echoes, compelling us to view colonization not as conquest, but reunion, blending human ingenuity with cosmic reverence. Yet, this reflection isn't solely somber. Mars's legacy ignites hope, a testament to life's unyielding pulse. Fragility, after all, breeds innovation on Earth. Crises spurred leaps like agriculture or medicine. On Mars, hypothetical societies might have forged underground havens or atmospheric shields, their failures lessons in endurance. This cosmic inheritance suggests resilience is woven into our fabric. If Martian microbes survived space's void to bloom here, humanity carries that fortitude, a spark defying extinction. Philosophically, it aligns with Stoicism, Marcus Aurelius's meditations on impermanence, urging us to embrace transience as catalyst for meaning. The red planet's desolation then becomes a beacon, warning of pitfalls while illuminating paths to longevity, perhaps through spacefaring that scatters our seeds beyond one fragile orb. What wonders might arise from this awareness, a renaissance in philosophy, blending astrobiology with ethics, where Mars's ghosts guide interstellar pacts against shared threats like solar flares or rogue asteroids. Cultural ramifications further enrich the enigma, reshaping art, religion, and society. Imagine literature evolving, novels where protagonists trace Martian lineages through genetic visions, or poetry evoking red dust as ancestral blood. Religions might adapt creation stories incorporating panspermia as divine dispersal, fostering unity across faiths. Socially, this legacy could dissolve divisions, shared cosmic fragility promoting global cooperation, as seen in international Mars missions, where borders fade in pursuit of truths. Education transforms two curricula weaving red-world geology with human evolution, inspiring youth to see themselves as stewards of a multiplanetary heritage. The mind wanders. What if artifacts surface a microbial fossil linking worlds, sparking festivals honoring the red migration, blending science with ritual? Psychologically, this narrative offers solace amid existential dread. Fragility, viewed through Mars's lens, becomes empowering. Life's persistence across voids affirms our place in a resilient cosmos. Therapeutic approaches might draw from this meditations, visualizing interstellar journeys, easing isolation by connecting to a grander lineage. Yet, shadows linger. If Mars's downfall stemmed from natural cycles, does it foretell our own, or empower prevention? Recent seismic models of the red mantle, preserving impact remnants, suggest preserved histories, blobs of dense material hinting at cataclysms survived, a metaphor for human endurance. Economically and technologically, the legacy drives innovation. Biomimicry from Martian extremophiles, yielding radiation shields or drought-resistant crops, turning fragility into fortitude. Space industries boom terraforming tech inspired by red world lessons, fostering economies that transcend Earth. But ethical quandaries arise. If we're Martian heirs, does it justify exploitation or mandate preservation? This tension captivates, a philosophical knot where legacy meets responsibility. In essence, Mars's reflections compel a re-evaluation. Fragility as teacher, legacy as bridge. The red planet's silent vigil warns of transience while affirming interconnection, urging us to weave sustainable futures. As rovers whisper biosignatures from ancient deltas' organic veils in sulfur-tinged stones, it beckons. Embrace this heritage. Let it guide our cosmic odyssey. What untapped potentials lie in this red-blue bond? A legacy that could propel us to stars, fragile yet unbreakable. Good evening, dear listeners. This is Mr. H from Mystery History for Sleep, your quiet companion whispering through the velvet night as stars align above, guiding you toward dreams woven with cosmic riddles. As we draw the curtain on our Martian odyssey, we stand at the edge of an abyss of unanswered questions, where the red planet's silence speaks louder than any discovery yet made. This is not a finale that ties neat bows around truths, but a doorway left ajar, inviting you to linger in the unresolved mysteries of Mars, its shadowed past, its tantalizing hints of life, and the siren call of possibilities that dance just beyond our grasp. Let this conclusion be a gentle handoff to your subconscious, a spark to ignite dreams where you wander red dunes, seeking secrets that defy time itself. What if Mars holds keys not just to its own history, but to the very essence of our existence, beckoning us to drift into the unknown? Mars remains a cipher, its surface a palimpsest where every crater, every mineral vein teases at stories untold. The leopard spots of Jezero crater, laced with organic whispers, and unveiled by rovers in recent explorations, stand as emblems of this ambiguity patterns that could herald ancient microbes or merely chemical mirages. These unresolved hints, sealed in titanium tubes awaiting return to Earth, embody the heart of the Martian enigma. Each discovery births more questions than answers. Were there rivers teeming with life, or only fleeting waters etching sterile stone? The methane plumes that ebb and flow, sniffed by orbiters, keep us guessing biological whispers from subsurface survivors, or geological sighs from a dead world. Science leans toward caution, demanding rigorous proof, yet the gaps invite wonder. Could a single fossilized cell, locked in polar ice, shatter our paradigms, proving life once thrived under a red sky? Beyond microbes, the spectre of civilizations lingers: pyramids in Cydonia, walls in Elysium, shapes that defy random chance yet elude confirmation. Are these Pareidolia's tricks, sculpted by wind and radiation, or faded markers of intelligence eroded by eons? The harshness of Mars, its storms, its cosmic rays erases clarity, leaving us to ponder if we overlook relics because they don't mirror our own. Recent seismic echoes from Landers hint at subsurface voids, potential refuges where artifacts or biosignatures might hide, shielded from the planet's relentless erasure. This uncertainty fuels a restless curiosity. What if our probes, inching across mere slivers of the surface, have already passed over ruins, mistaking them for rubble? The cosmic connection deepens the intrigue, with Panspermia suggesting our own blood might pulse with Martian ancestry. If life crossed the void, carried on asteroid arcs, then Mars is no distant stranger, but a lost homeland, its silence, a mirror of our fragility. This unproven link, bolstered by organic finds but lacking genetic proof, keeps us tethered to the mystery. Are we Earthlings alone, or descendants of a red dawn? The unresolved nature of this question invites dreams where you stand on Martian cliffs, feeling a kinship that transcends planets, a call to explore not just for knowledge, but for self-discovery. These mysteries, like stars half seen through mist, resist resolution, yet they compel us forward. Future missions, drills, piercing lava tubes, humans sifting regolith promise glimpses closer to truth, but the red planet guards its secrets well. Each unanswered riddle is a thread in your subconscious, weaving visions of alien seas or forgotten builders. As you drift towards sleep, let Mars be your muse, its enigmas a canvas for imagination. What dreams might unfold, revealing truths our waking minds can't yet grasp. Good night, dear listeners, from Mr. H at Mystery History for Sleep. May your slumber wander the red plains, chasing mysteries that whisper of worlds beyond, calling you home to the stars.